about yourself. All I need is what's your full name and what's your work profile, so that it'll be easy for me to understand what would be your ask. And please let me know what kind of roles and responsibilities that you'll be handling. So based on that, the examples can be kind of adjusted. Guys, can you introduce yourself? Am I audible? Oh, Lakshmi, can we unmute others?
Hello friends, hope you all can unmute and mute yourself now. You have the complete control.
Yes, guys. Can you unmute yourself?
Am I audible?
Yes, sir.
Yeah, Rahul.
So there is no chat section.
If you just see the, below your audience
Yes,
section,
yes.
there's a chat box. Yeah, I can use that.
Yes.
Yeah, can you have a quick introduction of yourself? If that's fine.
Yes, sir.
Okay, guys, I think it's better if we kind of have a two-way communication, because it's going to be like 3 days. And, unless you guys ask more questions, it won't be more fruitful. So let's start discussing. Okay, rather than just using chat, feel free to unmute yourself at any point of time, or any doubts or questions that you have, right? So let's start with a quick introduction, if you don't mind. Am I audible to everyone?
Yes, sir.
Yes, sir. So we
Yes,
should
sir.
start directly with,
Yeah, go ahead.
Yes.
okay.
So my name is Shrishal Gupte. I've done my engineering in computers from Rajiv Gandhi Institute of Technology. The college is in Warsaw, Andheri, Mumbai. And I'm very this cloud concept is much new for me, because we had this subject in semester 8, and because of the pandemic our semester 8 was not that good, as in for in a teaching perspective, from the teaching perspective. But yeah, we had this subject, and there was only oral examination for it. We had no written examination for the same. Just a week ago we had been done. No, I won't say done, but yeah, we have a little exposure of the AWS system, and so we understood the whole concept of cloud. Basically, what is cloud, what functions are there in cloud, and what services AWS provides. So Terraform is as new as AWS was for me for the last Monday. So let's. I hope that I'll understand this concept very well, and looking forward for it. Thank you, sir.
Okay, appreciate it. So if I understand, then are you a new college graduate who just joined recently?
Yes, I've been placed in NSCIT through college placements in September 2019. And because of the pandemic, we were supposed to graduate in May 2020. I mean, we were supposed to give the exam in May 2020, but that exam took place in October 2020.
Oh, okay, I get it. Thank you. Anyone else?
Hello, sir. This is Surbhi Chopdar, and even I'm a fresher. And I've completed my college from Thakur College of Engineering and Technology. And I am aware of cloud, but as we started off, Terraform is really new for us, and it's been a week that we are working on AWS. So we are now aware of it completely, but Terraform is really new. So I really hope that I'll understand more and practically give my best.
Okay, thank you.
Thank you, sir.
Hello, sir. Am I audible?
Yes, and by the way, my name is Adam. You can call me by that. Yeah, go
Hello,
ahead.
hello, sir. My name is Rahul Gupta. I have done my bachelor's degree in computer science from Atharva College of Engineering. I don't have any experience with the Terraform, so looking forward in this course to have good experience with Terraform.
Okay, thank you. So probably I see most of you guys are new college graduates.
Yes,
So
yes.
can I ask, is there anyone who's having a work experience here or prior work experience? Anyone?
No, sir, we are all freshers. Like,
No, sir.
Okay,
Like
okay, fine.
I have
And
an experience, but it is internship, not like work experience.
okay, okay, fine. That's completely fine. I get it. Okay, probably then there's one last question that I would have is, does
Hello,
anyone
Adam.
of you know? Yeah, go ahead.
Yeah, Adam, I'm Sanal actually. I'm Sanal Tuskanu. Hello.
Yeah, I can hear
So
you. Go
I've
ahead.
joined this NSIT in 2019 basically. So I'm having kind of a 2 years work experience over here.
Oh, that's nice.
Yeah, previously
So
I've worked
what
on
is your
service now.
responsibilities?
Yeah.
Okay.
So right now I'm just looking forward to learn Terraform. I've just gone through a couple of videos on YouTube on this Terraform mostly. So I just want to
Mhm.
gain a good knowledge of this Terraform basically.
Okay. So probably the question that I was trying to ask you is, you guys been learning AWS and you're going to learn Terraform, right? So does anyone of you know what is going to be your responsibilities on how you will be using? Any idea? Will you be working as an administrator? Will you be just, I mean, this is more for you to understand to help your day-to-day activities.
we have been told we'll be working
We
as an
have,
AWS core developer, so that.
So what is your primary responsibility? More into development, or will you guys be into operations or administration?
we have not been told yet. So
Okay, okay, sure, probably that you can find it out. Okay, thanks for that. Actually, that's the reason I was asking, because without knowing your background, if I just start getting into some other thing, it'll be difficult. Anyway, now what are the other tools that you guys know? Because when we say Terraform or any other tool, right, especially in the world of cloud and DevOps, there are a lot of small things that will be interrelated. So in that way, how familiar are you guys with other tools like Git or Docker, or do you know the basics of containers?
sir, I have no clue.
Does anyone know what is a container? Docker, Git.
Don't know, sir.
Like I'm aware of Docker a little bit,
Okay.
but I've not worked on it yet so far.
Okay. That's fine. No problem. The reason behind it is to give some examples, right? That's again I was asking. That should be fine. So see again. Let's go out from the very scratch. So that's what I'm going to do. So the only thing I would expect you guys is feel free to unmute yourself anytime, any question, because when we say Terraform or any other tool, it's just not only that. So to work, we'll be supporting a lot of other small tools. So that is where when I'm going through some example, I might ask you the same question like, do you know this? And if you are not aware, please let me know so that we can spend some time to understand, and then we'll jump onto the subject again. Okay.
Okay.
So yeah, with that, I'll assume a couple of things that you guys might not be aware, and I'll go from the scratch. Okay. Okay. Anyway, give me some time so that I'll just walk you guys through what exactly is the concept that we are learning. Okay, and then we will get into more of practical sessions. All right. So for maybe next 1 hour or so, sit tight and let's try to understand more of what is this concept called Terraform. Okay. And yeah, before that, just to give a small introduction, my name is Adam, and I've been working as an architect, as well as I do have more of a passion towards training. So I do more of technical trainings whenever I get time. So being in that, I've been worked into different roles like development and administration and kind of support various tools that we use to help an organization run their business, make sure how does the releases happen faster, and support the concepts called CI/CD. And on the other side, for any kind of deployments that we do, we need to have different environments. So we support that and also the infrastructure related to it. So that's where I did get chance to work on all the tools what we're explaining. So that's a small introduction about me. And okay, now jumping to the subject. Then before we go to understanding what is Terraform, I think let's first step back and try to understand what is infrastructure. Okay. Now, can someone tell me what is an IT infrastructure? How does it look like to you? What and all does it contain? So you join a company, and even in your college, you might have heard it. Now, whenever we say infrastructure, I'm talking something as a data center. So, okay, it's not the chairs and tools that you have in office. So I'm talking more about a IT data center. So what do you think a IT data center is all about? And what and all things do you have in it to do your work? Anyone? Or a simple question, what is a data center?
So data center basically consists of servers and storage devices, and which are interconnected to through cables and switches.
Okay, awesome. Anyone else? That's fine. So now, when you say data center, it's just about a location where you have a huge number of servers which is needed, and those are interconnected through some network. And ideally, this is where you would have learned in the last week or so that you can have a data center which is on premises, uh, wherein you can have physical hardwares or virtual machines or VMs using which you can create your data center, or moving ahead to the latest cloud concept, you don't have to worry about taking care of data center. There is a data center maintained by a service provider, wherein you just take their service. But now, if any kind of work that we have to do within an organization, so let's say whether you are a developer or a QA, or you are going to be a support person or an administrator, now for you, it is not just the data center which is needed. You guys need your own infrastructure to do a particular work. And this will be changing from person to person depending on what kind of work that you want to do, right? Now, that is where, if you actually say for a person in an organization to do the work, the infrastructure that he needs comprises of a couple of components. One is the machines or the servers, and then in that servers, you will be requiring some applications that you need specifically to work. And then these machines should be interconnected. So there is a particular type of network also is needed, because for QA, there might be a different type of network. And if you go to stage or production where a customer will access, there's a different type of network that you have. So these are the things which you would have learned in AWS, right? So in that way, by having a machine and a network around it and installing some kind of software in it, a person will get an infrastructure. But still, that alone is not sufficient. So on top of it, you need to have some user access to that infrastructure. Because when I say infra, it is not just a machine that you need, right? So if you're again a developer or a QA or a release person or a manager or an admin, for you to do the work, you need a machine, you need a network connection in it, and a particular list of softwares in it. And additionally, you need to have certain access to it. So all these things put together is what we call it as the infrastructure. Okay. So for every person day to day, if we have to do some work, there is a particular infrastructure need. But ideally, we will not be saying like for every person, we will be having an infrastructure. So we group the people, and based on them, we will be having a particular infrastructure. So for developers, there is an infra. For QA, there will be a set of infrastructure needs. And then, like I said, for stage or production, there will be something different, right? So like this, for every one of us, there will be a different set of machines being connected differently in a network, and you have different kind of softwares in it and different kind of permissions to access. So all these things is what put together we call it as an IT infrastructure. Okay. And now, as I was saying earlier, this can be on premises, or it can be used using some hypervisors or VM tools like VMware or OpenStack. Or on the other way, you can go to cloud, and in the cloud, it can be AWS or Azure or GCP. So regardless of that, for a user, we need this infrastructure. Okay. Now, when we say infrastructure, so definitely there is some person that has to maintain it. Or when we say infrastructure, it is not always that you will be creating new infrastructure, because the combination of these is what I typically was talking about, your infrastructure. And then any point of time, if you want to modify something in this, or if you want to add something in this, then there is a particular process that you have to follow. Okay, so what do you mean by a process? So I'm not sure if your organization is following a particular process, because in most of the organization, for changing the infrastructure, so they follow a process called ITIL. Okay, so in case if that's not in your case, it's not a problem, but there will be a separate administration team to whom you need to raise some request, maybe through a ServiceNow ticket, or there could be some other mechanism where you request them and they modify and get it. So whenever a person wants to work, he needs an infra, and it is a combination of all these things. But as an organization fully, if you see, it will not be just for a single person, then you'll have multiple people working on it. Now, in that, there is someone who needs to take care of managing this infra. So in that, there could be existing infrastructure where you might be just adding something or changing something or upgrading some applications or process, which could be one of the activity. Or for newer projects, you might have to create new environment for different people. So in that way, you might also be required to create new infrastructure as it completely. So again, I'm just taking AWS as an example. So there could be a AWS infrastructure that you guys are already using, which needs to be updated or modified or remove something which is existing. But if not, for newer projects or for new tasks that you want to handle, there might be new infrastructure that you have to create, which is where it comprises of all these things. Okay, so this is what which was being done everywhere. Okay, but the question now comes is, who is going to take care of all these things? So pretty much who has an idea of what is infrastructure and who knows what is data center networking, everything, right? But what are the problems that we face in managing an entire infrastructure? Or maybe for a particular team, if they want to modify any existing stuff or bring up a new infrastructure to develop a new project or to test it or to deploy or put into production, if they need any new environment or infrastructure, what is that they have to do? So the problem here is we walk or we go through a lot of manual process. So which is basically very slow, and these are prone to error. And suddenly if you want to scale, when I say I need something to work, not for one person, for 10 person, then how do you scale it immediately? So those kind of abilities are not there when you do all these things manually. Okay, now let's put another question. That you said you have AWS. Okay, now what if I say I want to do some work and I need a machine to work, but do you think that I can just go ahead and create a machine? Because ideally, so far what was happening, there will be a separate admin team to whom we have to raise some tickets. Okay, so that's what I said. Either you follow some ITIL process or some ticketing mechanism where you raise a ticket and that ticket has to be approved. Again, it will be in the queue based on how many tickets you are giving. And then someone has to approve, and then they will go ahead and create a machine or an infra for you. For which, what is that someone has to do? So assume that you had requested to create a machine, then the admin will go to the AWS console, and then he has to click those APIs or the dashboards, what you have seen. Okay, this guy needs a machine. So that means it's part of your EC2 service. So in the EC2, you will click on what is the AMI required and then fill all the other information on how many CPU, how much of storage, under which network or security group that you should be coming, what is the key that should be associated, right? Even for creating a machine, there's a lot of manual steps that we have to go through. So obviously, it's going to reduce the productivity, because just to create one machine, if we wait for even half a day to get these things done, that is not faster. Okay, because as an organization, now the whole concept of DevOps has been implemented, which focuses on how do we deliver continuously. Okay, so that is the word what we call it as CD, or continuous delivery. Company is expecting to deliver continuously to the customers or to the stakeholders. Now for that, for a simple machine requirement where even you have not done your actual development or testing, to do that when you ask a machine, and if that itself is going to take half a day or even a couple of hours, there's actually very slow in terms of your process. So that's where one of the issue we have. And second thing is, now think the same AWS infrastructure, which is very complex. At that time, if someone keeps doing everything manually, and there are chances that it is prone to error. And if they do anything which is unnecessary, then on the other side, in cloud, we know we are going to pay for everything. So it is not that you're going to get everything for free. So in those cases, if the person, whoever is managing, if they either do some over provisioning by creating something unnecessarily, or when they don't delete something at the right time, then what will happen? You will be still charged, right? So that's where AWS or cloud is very easy to set up everything, but if it is not being used properly, you will be billed at the end of the day. Okay, so that's the reason organization has to be very cost effective in every work. So how do you reduce it? Which is another problem that we have. Okay, and obviously, as I said, more and more management that you have to do in the infrastructure side, doing everything manually will definitely, tend to many errors. So that's where we need to start doing some automation. So that's the whole point that what we are trying to look. Now with this, okay, so this is where, okay, probably if you guys are not aware of Kubernetes, but just think on this way. So Kubernetes is more of a deployment tool or a deployment system using which you can run your applications very easily. So assume, now this is one of the trend where we have in the market for the complete deployments, we will be using Docker and Kubernetes. Now suddenly for a new project, what you have to do is you have to set up a cluster for dev in which you have a Kubernetes cluster completely set up, and there is a particular network being set to it, and they have assumed 2 machines in it to help that development team to work. Now for this, you need to set up an infra in AWS, and then once the development is done, when we move to the testing, which is QA, I need the same environment to be recreated, but there will be a small difference where I want to reuse whatever the steps I did, but I have to create a new network and more machines. And this is what we are going to give it for your QA. And the same thing further goes to your staging or pre-production or production environment. So in this case, what happens? How are you making sure that we are going to reuse the existing steps that we did? So now if you are doing all those things manually, then you have to start noting down all the steps. And in case if you miss any one of them, then when you do it on the second time, you have to sit and debug and try to do everything, which is time consuming. And this is not scalable because we are in a generation where, as I said, in the name of continuous delivery, it's been expected that everything should be done faster. So if I can do this, the expectation is within the next 1 hour, you should be able to get this, right? But practically, if you are doing it in a manual method, this will take more than 2 days to set it up. And that is where, for an organization, it's not just to automate the infrastructure, that is managing the existing infrastructure or to create a new infrastructure. We should be able to do it in a way which is more cost effective also. Okay, so that is one of the requirement. Now, let me take another example. So let's now understand what is the infrastructure. So assume that you are going to do some development activity on AWS. Okay, so what is the first thing that you need? So now you should be having a particular access. Now in that access, now when I say access, what will you have? So you will have your IAM. Okay, so as a particular user that you would be given access, you will be able to go to that console, or you will be able to use the AWS as a particular user. Now in that, we know that you can have a private network, which is what we call it as VPC. So VPC is a private network. So assume for a new project, you and your team would be working on a separate network because anything within this should be only accessible by you. So now for you to work, you need to first have a user created, and then you need to have a specific VPC created, and then you also need to have security group created for your team so that you tell what kind of traffic flows inside to it, and the same way what kind of traffic from the machines or the services that is inside will be going to the net or outside your VPC. So that is where your inbound and outbound rules will be given by security group. Then you need to create machines. And when you create machines, again, you need to create machines specifically based on a spec that you have given. And in that also, you need to make sure for an high availability, what are the different availability zones in which you can make sure it is available, and tie up this security group and subnets accordingly. Okay. And post that, if you have an application running, not just a machine that you want to access, then you would be having some kind of load balancer on top of it. So that way, if your interest is to access an application and make sure your application is always running, then it is not just only creating a machine and running your application, but surrounding it, you can see you need a subnet, you need a load balancer, you need a security group. And again, when I say VPC, there are a lot of other things that you will have, like internet gateway, right? Route table. Now everything has to be created specifically to your work. So this is where, assume this is your infrastructure for your development or for your testing. Then how many things that you have to do, right? So that's where doing all those things manually or in the traditional method will be a problem. So what happens now is, so far, let's try to understand what challenges that we are facing and how do we overcome, or what is that we need to do the automation. So there should be a need for us, right? So the need is, first, whatever that someone as an AWS admin or someone who wants to set this up as an infrastructure, how will they be doing it? So they will be doing everything imperatively. Okay. So what do you mean by imperative? So the meaning of imperative is you do everything manually, wherein you give step-by-step instructions and achieve everything. So for creating a VPC, so I should go to AWS console and in that to a particular service and give some input. And only after it is done, I should go to the another one. So that's where the current way of how you would have been seeing, and even when you learned AWS, whatever you would have learned is an imperative method. So wherein everything you would be doing step by step. Okay. However, what we now need is the opposite of it, which is declarative. So what do you mean by declarative? So declarative is a concept in which you are not going to tell each and every step that you want. You are just going to say what is that you need, and the system which is going to help us in achieving, which is what the automation that we are going to talk, will be taking care on how to achieve it. So that is what we call it as declarative. Okay. So anyway, I'll come to it a little later. But as I said, current way of working is imperative, which means you're doing everything step by step and you have to document everything, because in this, if I ask you which one you should be creating first, so you will say, okay, I will create VPC, then I have to create security group, then load balancer. But load balancer, I have auto scaling group, okay, auto configurations, that is launch configuration. So you need to set all those, and then you need to come and create a machine, right? So that's how you're going to put everything step by step in a sequence on how you want to run. So imperative represents you tell everything step by step. Okay. The next problem is scalability. So same thing. Now you created for assume one project. Now what if I ask, hey, can you do something similar to this for another 2 projects? Then can you do it within lesser time? Now again, you have to go through the same steps, and probably you might not take full time, but if someone else is doing, then they will also take the exact same time what you have done. So when you suddenly want to scale the entire infra, it is not going to be possible if you do imperatively, because you have to keep doing everything manually and step by step. Okay. Now, when you are working on your infrastructure, wherein you did everything imperatively, that is step by step, the infrastructure what you are going to have is generally called as a mutable infra. Okay. Now you might be hearing this word a lot. Now, what is mutable infra? So mutable means, assume that you have taken a machine, okay, and you're working over the period of time. the same machine will be going through lot of upgrades. Okay, that could be a OS kernel upgrade, or there could be some softwares that you have to update, right? So the same machine is what you are taking it for upgradation, or you are updating the same machine. The same way, if you take this network, the same infra, whatever you have, is what is going to be updated again and again and again for various requirements. Okay, so if the same infra is being modified many times or keep on updating itself, then it is called as a mutable infra. That is, you keep doing the changes in an incremental fashion. Incremental means if you assume this is there, now suddenly I will say I want to change something in the machine. Then I will add something to the security group. And same way for the load balancer, I might have to change some rules for the health check. So that way, the same infra, but you are modifying continuously on top of what is there, but you are not modifying everything. Only few things will get modified, which is what we call it as incremental. Now, what is the problem when we say mutable? Mutable means same infra is being getting modified on top of what was there earlier. And that way, over a period of time, you will not be able to get the history of what and all happened to this. Okay? Because now, simply a requirement comes, assume that this is one of the testing environment. If I ask, hey, there was some functionality that I was testing last week or last month for one of the customer. Now we gave it to customer, but they are saying there is some problem, and I want to get back the same infra once again. So how will you get it back? Okay, so that way, now assume this is where suddenly in this infrastructure I might have to add a database, and I will be doing one latest functional testing. But after some time, for another customer, I want to go back to that environment where I need to have everything which was earlier. So can you go back and give me an infra which you had last week? That is not possible. That is why it is called as mutable. So you cannot go back at any point of time to the same infra, because once again, if you have to do, you need to know what was there at that time and how do you document it, and based on that you have to redo everything step by step. Okay, but what is that we need for modern deployments, modern development and testing, and to achieve continuous delivery, we need our infrastructure to be the opposite of mutable, which is immutable. Immutable means I don't want to take the same infra and keep on modifying on top of it. All I have to do is in a way that if I need a change, I should be creating everything quickly in a short time, and I should be having a complete history of what and all modified, so that if you ask me last month what infrastructure did you had, it's not just infra means one machine or one database. I want to get back everything considering this diagram. So that is where whatever ask as an organization is, how do we get a immutable infra? Because if you keep modifying the existing one, we will lose the details of what we are doing, and it will be difficult for us to track back or go back. Now, instead of that, we need to have the system in a immutable infra. Okay, so which is another thing that we are trying to go through. Now, finally, what it comes is, all right, now this is your infrastructure and this is in AWS. What if tomorrow, okay, it may not be tomorrow, in the sense tomorrow, like as you move forward, your organization might feel that a couple of services in AWS might not be suitable for a project. So even though you are using AWS, they might also explore Azure or GCP for some services, may not be fully, but for some services. Then what will happen? Now, whoever is going to manage the infra, it is quite necessary that you should be taking care of AWS, and the same kind of things you should also be doing it in Azure or GCP. So how will you do? Now, this is where, if you go back to AWS, there is something called as CloudFormation. So using CloudFormation, you will be able to manage some infrastructure and automate whatever you have only in AWS, right? But what you have others outside, okay? Now that CloudFormation will not be useful if you go to Azure, or pretty much if you go to what do you call it, the GCP. Then what will happen? Now in that, for Azure, they do also have something different. So now it will be quite difficult for someone to manage multiple things, because assume that CloudFormation has a specific syntax, and then Azure has a specific syntax of a different tool what they have. So in this way, what will happen? It's quite difficult for a person to manage, and that is where what we need is, as we move forward, we need a solution which can be declarative, so that you tell what you need, okay, or you tell what is your desired infra, and the system what we are going to think of should be automating the creation of infra. So you don't have to do step by step, you just tell what is your desired state, and the system should take care of it, and that is what we call it as declarative. And that system should be highly scalable. Okay, so when I do this for one project, I should be able to do the same thing for multiple projects. And that system should help us to create a immutable infra. That means it keeps a track of each and every change that is happening. And I don't want to keep on adding the same on top of the existing. Instead, you should be able to have the control to recreate everything any point of time. Okay, and finally, the same system should be able to connect to AWS, or if I need, it should be able to connect to Azure or GCP. So that is what we call it as cloud agnostic. Agnostic means not dependent to one. Okay, so this is where we need a system which is going to be what? Declarative, scalable, and immutable infra, and then cloud agnostic. And this is where in AWS, you already, or you might have already seen or heard about CloudFormation. Okay, but that is only for AWS. But as you have different kinds of cloud services, then managing multiple service providers will be difficult, or it is not at all possible when you use something like CloudFormation. So that is where we are moving ahead to manage with a better tool or a better system. Okay, so with this, now if you come into the picture, Terraform comes into. Okay, so what is Terraform? So now if you see, Terraform is a automation tool. Okay, so what is it going to automate? So it is an infrastructure automation, or rather than calling it as automation, we can call it as an orchestration tool, because it can do so many things for you. Okay, so mainly to orchestrate and automate your infrastructure requirements, you will be using Terraform. So using Terraform, what you can do, you can completely build your infrastructure from scratch, or if there is any existing infra, you can just modify it. Okay, so that way Terraform is purely meant for managing and controlling your entire infrastructure. Okay, any questions before I jump further? So what is that you're going to do using Terraform? You're going to manage your entire infra. So for now, you guys know cloud. So anything that I need in cloud, I can manage the entire infra. Okay, so this is where AWS is there. But like I said, when you compare with my previous diagram, if this is my infra, how do you get this done? So if you keep doing it in an imperative way, this is going to be time consuming, and this is not scalable, and that is not immutable, because you cannot maintain the history. And that is where tomorrow, if we ask for any other service provider, then it is not going to work. And this is where, instead of we doing it in an imperative way, we are going to do it in a declarative way, okay, wherein it is highly scalable and it can keep a track of everything. And Terraform is cloud agnostic, which means using Terraform, you can tell what is your desired state, which is in AWS or Azure, and Terraform will automatically get the things done. Clear until now? Any questions?
So,
Yeah, Adam here.
yeah. So, Terraform builds a new infrastructure from scratch in a declarative way, as well as it can update an existing infrastructure, right? But
Exactly.
in the point number 3, we had been told that we need immutable infra. So you cannot make an updates on an existing infra, but you can have a new infra with those updates. So if we are having a immutable infra, how can Terraform update that existing immutable infra? I
See,
hope
when you
I'm
say
clear.
immutable infra, it is not that everything will be recreated, right? So what happens, to give you an example, you have a machine, and in that machine, if you are trying to change some property, immutable means the old system will be deleted and you will be created with a new machine. Okay, wherein with the property. So now try to understand, I'm not talking about what is inside the machine. I'm talking only about creating a machine. Now let's say security group. Now for this security group, I don't have to delete and recreate, because on the same security group, I can modify certain things, right? Just by adding new rules or removing new rules. But only for certain services, you can actually apply wherein that immutable concept will be considering. Wherein when you see, this is where you should stop seeing everything as an individual service, but as an entire service, you have the ability to keep a track. So immutable means you can have a track, and depending on the type of services, rather than just modifying on top of it, you can completely recreate. Okay, so it's a combination of both, but ideally it depends on what kind of service that you're taking, whether you want to recreate or whether you want to update. So that's based on the service and what options we are using. As we go through, you will see. Okay, but don't think when I say immutable, if I want to change a machine, your entire VPC security group, everything will be changed. Only certain things will be recreated.
Yes, sir. Yes, sir. I got it.
Others? Okay. So now if you see, Terraform is a tool for infrastructure orchestration, where whether it is a complete new infra or whether it is an existing infra, you're going to manage it using Terraform. Okay, and for that, it doesn't matter whether it is going to be in AWS or Azure, it's going to completely handle it. But how is it going to handle? So this is where I said, you are going to tell the desired state. Okay, so what do you mean by desired state? So if you take this example, I will say, okay, to do some work, my desired state is I need to have a particular account in which I would have a VPC with a security group and a load balancer and some machines and connected to a database. So this is what I call it as my desired state to do the work, right? So which way? This is your desired infrastructure. So whatever that you need, so you're going to put it as a code and give it to Terraform. Okay, so you're going to tell that desired state, and how to achieve it, and what are the dependencies for that, everything will be taken care by Terraform. That is, you tell what is your desired state. However, how to achieve it will be taken care by Terraform. So you don't have to go and click everything. So you just put your desired state, that's all. But how do you give that? So which is where Terraform works in a declarative concept. So when you say declarative, you put everything as a code. Okay, so when I say code, it's not a program. So it is a particular set of syntax through which you are going to give an input to Terraform. Okay, so this is where what is your desired state of your infrastructure? You put it as a code and give it to Terraform, and Terraform will try to take that and it will try to achieve to bring whatever is your desired state. And since whatever the infrastructure that you need, you are trying to put that as a code in a declarative way and you're giving it to Terraform, the whole concept of creating an infrastructure through some code is actually called as infrastructure as code, or IAC. Okay, so internally, how does Terraform work? So Terraform works in a concept called IAC, which is nothing but infra as a code. So I was telling you, right, you have to specify or give your desired state. So now there will be a file in which I have to write some syntax, which is what we call it as code. And in that code, we will tell, hey, I need a VPC, I need a security group with so-and-so rules for inbound and outbound, and I need a load balancer with these health check, and I need a machine with these configurations, and then a database with so-and-so configuration. So you are going to just tell your desired state of your infra. And then the Terraform will make sure to create this. And for that, whatever the dependencies are there, it will be managed by Terraform. So that is how you tell what is that you need as an infra in terms of a code, and that will be taken care by Terraform to achieve it. And this logic where you are putting your infrastructure or converting your infrastructure in a code and running it in a declarative format is what we call it as IAC, or infrastructure as code. Okay. Now, why is it being so popular? Because now, whatever the state that you want, you're going to just put it in a file. Okay, and that also, it's not a file where you have to specify everything to run manually, because there might be a question now, or probably when you have gone through AWS, you might have learned there are a lot of APIs available using which you can connect to AWS programmatically. Like you can use Python, most preferable way, and using Python you can connect to AWS through CLI or programmatically, and you can do the same automation, right? But assume if I'm asking you to write a Python program or a shell script or any other programmatic way, then to achieve this you need to tell everything, right? What should be the command or API to invoke to create VPC, and for that what are the input, and then what is the command that you have to input to this, right? And then what API or command to call. So you have to tell everything. Now that is for a new infra, but for an existing infra, what will happen? You have to first find out whether this is available and that has all the properties that you want. If not, assume that I want you to automate something where on an existing security group, I want you to add a new rule. So now first tell me, you cannot directly write a Python or a program or a script which will just connect to AWS and add. But what if the security group is not there? Then first you need to find out whether this is available. So there should be again some kind of additional lines of code or API that you have to write, and then take the result and evaluate and check whether the security group has the rule what you want. So there should be conditions that you have to put, and only after that you are going to say, okay, the security group is available and in that the rule what you want is not there, so let me add. So finally you will be putting that command. But what if the security group itself is not there. Then you have to first write a command or an API call, which will create this and then add. So this is how, by writing a program or a script, you are doing everything in an imperative way. So even though I can run it, automate it, but that is not declarative, that is imperative. So if I ask you tomorrow to do something else, then the more and more you keep adding into that, you will be, making it more complex, and that is where it will be very, tedious to change, and again, it's prone to error. So it takes a lot of time. And instead of all those things, in Terraform, you're just going to have a particular syntax in which you just tell what is that you need. And this is where Terraform itself will check the same, wherein it will not ask you how to find out if a security group is there or not. It will just say, okay, if I say I want a security group in which there is an inbound rule where port 80 is allowed, that is what I want. So what will Terraform do? It will check whether the security group is available. If it is available, whether you have your port 80 added in inbound rule. If it is not, it will directly add. Okay. If that security group itself is not there, then Terraform will create it and then add. So that is how you don't have to tell on how exactly to do. Whereas if you write a program or a script, that is called as imperative, because you have to write a lot of code and tell everything exactly on how to achieve. Okay. So this is where, since you are trying to give such a kind of a declarative syntax in terms of a code, you can store it in a file. That is the major advantage. Okay. And second, so whenever you say that you are writing anything as a file, then it can be reused, correct? Because if I have this infra, and if I want to apply the same to another project with just minimal changes that I have to do for the input, I can typically recreate it any point of time, and I can reuse it as much as possible. And that's where your scalability comes into the picture. Okay. And the next thing is, it's easy for you to test, because now if I want to get this environment for a team, I can run it against my IAM and quickly test it, so that the actual users will not be affected, correct? So testing will be very easy, because I can take the same file with the same desired state, whatever I have given. If I run it against my IAM, the whole network and setup will be created for my user, where I can test, and quickly I can destroy it later. That is also another advantage with Terraform, because assume you have created this. Now if you have created all these things programmatically, or if you're doing it manually, what if I ask you, hey, this project is no more needed, destroy everything? Now that is where, if you are trying to do manually, you have to go to each service respectively, and you need to know how it is interconnected, and you have to stop those and delete those. But by mistake, if you don't delete something, and if the service keeps running, you will be charged, which is what is the problem in the imperative. Whereas now, like how you say, the state is I want it, Terraform will create. The same way opposite, if you say my state is I don't want this, then automatically Terraform will delete everything in a proper order. So that is where you're not going to spend too much of time in debugging or manual steps or error prone, whereas this is very, very cost effective way of doing everything. Okay. And that's when, for all this, it's always easier if you write the desired state what you want in terms of a code. Okay, getting it? So that is why we call that Terraform internally works in a concept called infrastructure as code, wherein what is that state you want, you put it in a file, and that file is what Terraform is going to read, and it is going to achieve the desired state. Whereas since you are trying to write everything as a file, this is easily reusable, and you can easily test it, and you can also version it. Okay. Now, when I say version, has any one of you have any idea of what is version controlling system? Or heard about any tool like Git Perforce or SVN or Bitbucket, anything? Or in AWS also you have this, right? Anyone? What is version or what is version control system? Okay. So what happens when we say version controlling system, right? Now, most probably when we have the developers, okay, now they write lots and lots of files, which is programmed. Now, where do they store everything? Because when I say there is a project and it has been under development, assume that there is at least 10 developers who are going to write some program. So do you think all of them will just write one file? No, each one of them will be writing multiple files, and in each file, multiple lines will be modified once again, multiple times, correct? Because in a day, I might change 10 lines and again, another person will change another set of lines on a different file. Now, all of them has to be tracked because the same problem, what happens, when I want to now create a product, I want all the program files from everyone. So which one will I take? And what if there is a problem? I want to go back the same way that, hey, yesterday I was writing this file. I want to go back to that content. So how do you keep a track of each and every line that is getting modified in a file? Or when you have your project with thousands and thousands of files, and that is where we have a concept called version controlling system. Okay, so the most popular one what we have right now is Git, but still there are different options that companies might use. So now what we will do, so as a developer, when you're trying to write your code, so you need to store it somewhere at the end of the day, in which we will be able to track on what and all changes was done and who has done it. And the same way, now when I say Terraform follows the concept called infrastructure as a code, so now you're going to take a file and you are giving your desired state. After some time, you're going to change your desired state whenever it is needed. Now, are you going to do in the same file or will you keep multiple copies of the file? That is not possible, right? So you will take the same file and keep updating. Now that is then the same question comes back. If I ask you to tell me the desired state, what I had last week, how will you get back? So this is where whatever the code that we are trying to write or a file that you're going to write in Terraform, you're going to store into this version controlling system like Git, where every time you modify something and put it back into Git, it will be giving a track of who modified and what was modified. So this way, now suddenly if someone comes and says, hey, last week I wanted to, last week I had a project requirements for which there was some state modification I did. Can you give me the file which I had last week? So easily, if you ask the Git will give you the options to choose, and you can take the exact content of your file at that time and run that against Terraform, and Terraform will bring back your old infra. Okay, that is where by writing it as a code, you can store it into a place like Git and you can version it. Version means tracking everything. Okay, so each changes that you do. Probably in S3, you might have heard about this called versioning, right? So if you store an object in S3 bucket, every time you keep modifying it, you will be having a separate version of it, wherein if you want to go back to the previous copy of the file, it's like go back to the version of that and you can exactly get the same file with the same content. The same way, now when we talk about development, and it's not just only developers, but now almost every one of us have to write some kind of file. So whether it could be some kind of program or it could be some kind of script like a shell script or a PowerShell or Python, or it could be even a document, a text file which is needed for some configurations. So regardless of that, you're going to store everything into a system called version controlling system. Okay, and this is where you're going to version it. which means maintain a history on who and all modified. And in that logic, now if you see, Terraform works in infrastructure as a code where you can write a file which will have your desired state, and that can be completely reusable. You can test it again, as well as you can keep a track of who is modifying and what and all has been modified. And this is how Terraform is a complete tool where you can manage your infrastructure fully or orchestrate your infrastructure, which is an existing infra or it's a new infra. Okay. Clear until now? Any questions? Do you
Hello.
understand what is Terraform now? Yep.
Yeah, so is the versioning done over here automatically, or we have to do it manually every time we update something?
Terraform doesn't do the versioning, but the concept, what I'm saying here is, Terraform works in the concept called infra as a code, where you have to write a code which will be used by Terraform. So now, since you're writing it as a code, you can store it into a system like Git, and using Git, you will be able to track it.
Yeah, okay, thanks, I know.
Okay, any other questions? Okay, so if you keep silent, there is only two meanings of it. Either you understood everything or you didn't understood anything. So is this clear so far on what is Terraform and what do we mean by IAC or infrastructure as a code? What's the difference between writing a code for Terraform or writing a script like Python or any other program?
Yes.
Yes, sir. I understood.
Okay, fine. Again, I'm saying feel free to ask questions because there are small things. This is where I said, you need to have a couple of basic knowledge of other tools, but anyway, feel free to ask if you don't know certain things. Okay. All right, probably now I have to talk a little deeper because this is what was expected. Okay. Since we say Terraform, it's not about just commands to learn, right? So basically you need to know the whole gist of what is it, why is it. So what are the major features of Terraform? So the first thing that we need to know is it works in the concept called infrastructure as a code. So what you're going to do, you're going to create a file, and in that you're going to give a declarative syntax, and Terraform will take care of managing it. Okay. Now, Terraform has an option called as plan. So what do you mean by plan? So assume that I want you to create a machine, okay, a simple requirement. So if you write a script like shell script or a Python script where you are using the AWS CLI, now what will happen, or even if you say Terraform, sorry, the cloud formation. Now what will happen here is, do you have an option to check on what is it going to do and what are the resources that will get affected when you are going to run the script? There is nothing like that, right? Because if I just go ahead and run my shell script or a Python script, it will just connect to AWS and then it will just create the machine, right? But will it tell you what and all it is going to modify? or the same security group example that I was telling. I wanted to make sure that I have a port 80 available, but for that, whether you are going to create the security group or you are going to modify a security group, we don't know. And this is where, by writing your manual script, it is not possible to know what is exactly available and what is that currently you're going to do. That is what Terraform is going to benefit in. So when you execute Terraform, you have a step called as planning, wherein if you tell that Terraform to plan, what Terraform will do, Terraform will try to stake the desired state what you have given in the file and compare it with the actual state available in your infra. Okay, and while comparing, it will tell, okay, see, you asked me saying I need a security group with port 80 in the inbound rule. Okay, this is what is your desired state. And now if I look, it says security group is there, but the inbound rule doesn't have port 80. So what I should do now? So it will tell you, if you actually run this code, then what I will be doing is I will be creating an inbound rule in the security group. And this is what is the plan will show. Suppose if the security group itself is not there, then the output of the planning, what Terraform will say is, Terraform will say, hey, against whatever is your desired state you have told, what I have to do now is, I need to first create the security group, and then in the security group, I am going to add a new role. It will clearly tell you. The same, if the security group is also available already and there is also inbound rule, then when you try to do the plan, Terraform will say, hey, I don't see there is any difference between your desired state and the current state. And because of that, I'm not going to modify. So before you actually go ahead and modify or create your infra, by doing a planning step, Terraform will clearly tell you what and all are the resources which is going to get modified or updated or deleted or created. Okay, so that way you can know that whether you have written your code properly, because it's not always that when I write my code or state, I have defined everything. Because in production level, if you say by doing some small mistake, it will take a lot of time for us to fix it. And that is where, before you do any change, you can do a planning step in Terraform and exactly find out what is that it is going to change in the actual environment. Okay, so which is not available in any of the other tools, or when you try to write your own script, that is not possible. Okay, which is another biggest advantage of Terraform. And then when you try to run Terraform, it generates a graph. Okay, so what do you mean by graph? So it generates a dependency. So for example, if I want to create a machine and a security group and a VPC, then based on how you give the input, Terraform will know that there is a dependency that I can create, and based on that, it will create the VPC first, and then the security group, and then it will be creating the machine. Okay. However, if there is no dependency between certain services, Terraform will create the resources or the services in parallel. Okay. Now going forward, when I say service of AWS, it is the same as a resource in Terraform. So resource is nothing but a particular step or a service that you want to modify or create. Okay. So that way, if you are creating your entire infra, what and all has to be created in parallel, what has to be created, in sequence depending on dependency, that will be planned. So in the plan, it will generate a graph, and this is what finally you are going to modify or apply later. Okay, and this is how in Terraform, before you go and modify something, you have to first do a step called planning and see what and all is going to get modified and what is the dependency. And based on that, when you try to apply the changes, what will happen? Terraform will basically apply it. So this is where these are the features of Terraform when compared to other tools. Okay. Any questions on execution plan or the graph feature?
We don't
Hello.
need to provide that in the inside the code, right? Resource graphs are automatically generated.
Not fully. There are some dependency we have to give, but it is not like you are going to explicitly give the dependency. But when you are trying to run Terraform, when there are multiple resources to be generated, Terraform knows based on what is your desired state. So this is where it's important for us to tell how this desired state is going to look like. And based on that, the Terraform can generate a graph or a tree which says what and all is needed to run in parallel, what and all is needed to run in dependency.
During plan state, it will notify us, right, that which VPC is created and which server is created in which VPC and in which security group.
Yeah. So typically that's what the plan will tell you, right? But which VPC will be created, that is the input what you are giving. But what the plan will tell us, it is going to generate a new VPC. It is going to generate a new security group, or same security group is getting modified, or same security group is kind of getting deleted. So those kind of information it will give you.
So by chance, if we have missed to mention the VPC into this the machine which we have created, and
Obviously nothing will happen. This is where you need to tell, see,
okay,
Terraform knows how to create a VPC, but
mhm.
unless and until I don't tell what is the name of the VPC, how will Terraform know what to create? And unless and until I don't tell where exactly it has to create and which region, how it will give. So you have to give those information. So if you are interested to create a VPC, then some couple of the inputs you are going to give is under which region you want to create, under which user account that you want to create, and then for VPC, it needs couple of information like your, what is it? The CIDR range. So you're going to give the CIDR range and the name for your VPC. So based on that, Terraform will create, but you don't have to tell the exact command, what you have to execute first, what you have to execute second. That is what we call it as imperative. Declarative means you will say, hey, I need a VPC which should have this name and which should have this CIDR block range and which should be created under this region. So you tell it, and that is what it will create.
Okay, thanks, Adam.
Okay, so if there are no questions, now how does Terraform work, right? Okay, now when you say Terraform, it's a single component, so you don't have to install it on multiple machines. So you take a machine in which you want to install Terraform, and typically the component that you're going to install is what we call it as Terraform core. Okay, now in this, what will happen is when you install Terraform core on that machine, all you have to do is give some input to it. So that way, first try to write the code that you need, which is what we call it as the infrastructure as a code. So typically, Terraform uses its own syntax, which we call it as HCL or HashiCorp language. We will go through that. And you first write the code, which is your desired state, and then give this file to Terraform and say, hey, I want this state to be available. That's what. So you just tell your desired state. So what will Terraform do? So Terraform will read the desired state from your configuration that you have given, and then it will try to first connect to the desired, whatever this the service provider, like in our case, let's say AWS, and it's going to generate a state. So what is that state? Which is nothing but what is your desired state and what is the current state. And based on that, the first thing that it will do is planning. And in the plan, we will know what are the things that is going to get created or get modified or updated or deleted. And in that also, what is the order that will be managed by Terraform. And once you have first planned and you found, okay, these are the things which is going to exactly get modified or getting deleted. And then once you are sure of, okay, this is what I want exactly, okay, and then you are going to apply the state, whatever that you have told. Okay, so when you apply, what will Terraform do? So Terraform will connect to those service providers like AWS, and in that, it will be updating the infrastructure to bring your exact infrastructure, what you have told. Okay, this is what Terraform will do. So every time you want to update, all you have to do is write your code or update your infrastructure as a code and give that to Terraform. And Terraform will first do the plan and you can find out. And if you feel that's the right thing, just go ahead and apply. And based on what you have given and what is not available in the actual state, so Terraform will update your infra to be exactly the same as your desired configuration. Okay, so for this, all you need to do is install the Terraform core on a machine, and you're going to write your code, which is in a infrastructure as a code syntax, and give this to Terraform. Now for doing this, Terraform uses plugins. Okay, because since Terraform is cloud agnostic, Terraform can connect to AWS or Azure or VMware or anything else also is possible. Now for all these things, it uses a plugin, and those plugins are generally called as providers. Okay, so this is where now when we are writing our configurations as a desired state, so we need to tell what kind of provider that Terraform should be using, and in that provider, what are the different resources it is going to manage. So all those information you are going to put it here. Okay, so this is how ideally you will be getting the Terraform executed. So make sure Terraform is installed in a machine, and on the same machine you try to write your file and give that as an input to Terraform. And the first thing what you're going to do is a plan where Terraform will take your desired state and it will take the actual state and it will compare, and depending on that, whatever is the change needed on the desired state, it will go and apply. And there is nothing needed, then it will just clearly say your infrastructure is up to date, because what you wanted in the desired is what is actually available in the state. Okay, clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
All right, now I think this small steps that. So what is the Terraform workflow that you're going to do now? Okay, now the very first thing all you're going to do is write your code. That's the thing. Okay, now this is where you need to understand, when you say you write a code, it may not be always that you will do in a machine. So you might have to write the code and store it into a version controlling system like Git, and then you're going to copy the files from the version controlling system like Git to your machine where Terraform is there, and then you're going to execute. Okay, because practically you will not be modifying everything on the same machine. And this is where, before this, the version controlling system comes into the picture. So you write the code because you are also developing a code. Developing a code is not that you have to develop a program. This is also called as developing a code. Okay, and you will also store your code into a version controlling system like Git, and from that you're going to pull whatever that you want or what version of the file you want, and then you're going to execute. Okay, but when you're practicing, you can just do everything on the same machine. So which is where first write your code, get it reviewed by your seniors, and once that is done, then you run Terraform and do the plan, and which is where you are going to review the changes before applying and confirm that this is what exactly you wanted, and then go ahead and apply. Okay, so this is the 3-step process on how you run Terraform. So write the code, do Terraform plan, and then do Terraform apply. And what will apply do? Whatever the plan you have done, that exactly it will apply. Okay, so remember these are commands which we will go through. Okay, but this is the workflow. Write the code, review the code internally, that's part of the development, and then do the Terraform plan and see what you needed, and then you do a Terraform apply. Getting it? Okay, so now one of the last thing that I want to talk from the concept is, okay, so we've been hearing about Terraform a lot, right? Now, there are a couple of other tools in the market. So are you guys aware of this? If not, I will take it later. So do you know what are these tools stand for? Or have you heard about these?
Heard about Ansible.
No, sir.
Okay, fine. Then let me not go deeper, because unless you don't know the concept of it. Okay, but now there might be some confusion in case if you guys have used this tool. So how is it different? Okay, so what is Terraform? So Terraform is a infrastructure orchestration tool. That means if you need your entire infrastructure created or modify an existing one, you're going to use Terraform. In that way, now, if you go back to this previous diagram that I was showing you, so Terraform will create a VPC, security group, load balancer, a machine, and a database. But what if you need inside the machine, you need to install some softwares, or what we technically call it as packages. You want to run some scripts, or you want to run some services like start some service, stop some service, right? So those kind of things Terraform will not do straightforward, because that logic is called as configuring a machine. Okay, or in simple, the other logic in DevOps, like how infrastructure as a code is what we are seeing now. But given a machine, if you want to configure it automatically to be available in the same state whenever you want, then that is called as configuration management. Okay, so for example, you created a machine. Okay, but for me to do my development work or testing work, let's assume I need to make sure that a specific version of JDK is available, or the Java development kit is available, or I need a specific version of Node.js in it, or I need some service that is some application like Apache or Nginx running in it. So now, like how if you say the desired state for your infra, what you can do is, the logic of configuration management is you tell the desired state of a machine, not the infra. So given a machine, inside the machine, how do you make sure that automatically the state is available? So just like how we did here for the infra, so you don't have to tell everything like, oh, go to this, find whether this command is available or not, and then install it or upgrade. So instead of you doing it, you can tell it as a code, and that will be managing your configuration of a machine. So that logic is what we call it as configuration management. Okay, so ideally all these tools, Ansible, which is what is most popular, and prior to this you would have Chef and Puppet. So this will be mainly used to manage a machine, and inside a machine automatically configure. So for example, you will now have a machine, and I want to make sure that machine has specific version of Java, specific version of Node, and then Nginx service running. So I will give these three things as my desired state, and when you run this tool like Ansible or Puppet, it will connect to that machine and find out what is not available and exactly make sure that configuration is done. So that is where a machine level configurations to make sure it is in the same state what you want is what we call it as configuration management. Okay. So clearly, it's not like a demerit of Terraform, but Terraform is meant for infrastructure. So Terraform will just create your infrastructure and stop. It will not go to the machine and configure the machine to make sure it is in the desired state. So for those kind of activity, we will be using another tool called Ansible or any of this, and these work in the concept called configuration management. Okay, so that's the primary difference. Terraform is more of an infrastructure provisioning or orchestration tool, whereas these tools mainly work on an existing machine and configure it automatically, which is configuration management. Okay. Then mutable versus immutable. This is where if you take all the other tools, so these work in the concept called mutable because it is the same machine in which it will be keep on updating, installing anything that you want. But when you take Terraform, there are chances where there are entire service or the entire resource will be recreated. At any point of time, you should be able to completely get it back. Okay, and that's where strictly Terraform works in an immutable, and these tools work on a mutable because you give a machine available, it will go to that machine and it will update the machine. But Ansible or Puppet will not recreate the machine to bring your desired state. Whereas those kind of things is what Terraform will do depending on the service or the resource. It will recreate your entire infrastructure as per the need. Okay, and that is how you will be able to track everything. And how to do that? So there's going to be a file. Okay, so that's another difference where these tools work in mutable way and Terraform works in immutable way. Now, once again, procedural and declarative. Now, pretty much Terraform and CloudFormation, both of them work in declarative. But Ansible and Chef, if you take, these tools are not declarative. This is more of procedural because you have to tell everything step by step. But again, this is not like an apple to apple comparison because again, as I said, Terraform is meant for your entire infrastructure, whereas these tools are for given machine to configure. And then master versus masterless. So if you take this tool like Chef and Puppet, you will be able to work provided you need to install, there is something called as master on one machine, and on each and every machine that you want to automatically configure, you need to install an agent. Whereas in Terraform, you don't have the concept of master and slave because you are not using Terraform to connect to a machine. You are using Terraform to connect to your AWS. So for that, it doesn't need anything. All you have to do is install the Terraform core on one machine, and that will use the plugins called as provider, and it will be connecting to AWS or any other service that we need. Okay, that is what the agentless is also. And pretty much the last one that you see now, earlier these tools were quite popular, and when AWS started emerging, they introduced the concept of infrastructure as a code, for which they used CloudFormation. But eventually what will happen is when other service providers started coming up, we needed more of a cloud agnostic way, and that is where Terraform started getting popular. So that way, now if you understand, for any kind of infrastructure management or orchestration, whatever you want to do, you're going to use Terraform. If there is a automation that you need to configure a existing machine, then you might think of using Ansible, which is the latest, or Chef and Puppet will also work. But in reality, for managing your data center, it is a combination of different tools that you're going to use. So that way, you're going to use Terraform to create an infrastructure or to modify your existing infrastructure or to delete the infra. And inside the infrastructure, when you have different machines, you will use Ansible to combine with Terraform and you can manage the configuration. Because now I can trigger Terraform to create an infra, and Terraform can call Ansible, and Ansible can configure a particular machine. So this is how you can manage your entire infrastructure by using a combination of multiple tools. So you can use Terraform and Ansible for that. Okay, but let's assume your requirement is to create an infra, and in AWS we have this logic of creating your own custom images or custom AMI. So how are you going to do it? So rather than once again doing it manually, we can automate it using a tool called Packer. Because again, Terraform will not help you to just create an image. See, if you just say create an image, it will create. But inside the image, what and all steps you have to put, what you have to modify, that Terraform cannot help, because that is more from an infra level. Just like how I told, within a machine, it will not be able to do the same thing. Terraform cannot help you to create a custom image. See, all it will do is run some command. But if you want to custom and create your own AMI, then there is a tool for that called Packer. So that way, you can use these two in the combination to create an infrastructure and a particular image which you need, and then using the same image, you can create a machine. So in those cases, you might have to use a combination. But suppose, let's say you are trying to create a deployment environment for dev, QA, or production, then you need to create an infra with your VPC, security group, machines, load balancer, database, whatever. That is use Terraform. But inside those machines, you need to deploy certain things, which is your application. So this is where now Docker and Kubernetes will come into the picture. So what we can do, now you can use the combination of Terraform with Docker and Kubernetes to make sure you are creating a deployable environment. So this is where it's a combination of different tools that we are going to use to achieve what is that exactly you need. Okay, so that's the whole logic of DevOps. So it is not just about one tool which will do everything. So it's combination of different tools. Okay. Anyway, I'll show you these combinations as we go through the advanced session. But pretty much before we jump into the core Terraform and start focusing, and this is just a small introduction wherein by now you should be clear what do you mean by Terraform and how does Terraform work, or what is the basic difference between Terraform and other tools. Okay, so any questions in this?
So, sir, we can look Terraform as a code or as a language which is used to build an entire infrastructure.
Yes, build a new infra or modify an existing infra.
Modify an existing, and also this language combines with other tools to make changes inside that infrastructure at a lower level.
Exactly, because Terraform stops only by creating a machine. Okay, but if you want to customize your machine to a desired configuration, then you would be using a tool like Ansible. So Terraform will not do. Same way, you want to create your own custom images for AWS, then you use Packer. But if you want to create your environment which is deployable, and then you need to make sure you have Docker and Kubernetes. But all this can be combined with Terraform because you create infra or you modify infra plus you configure that infra using these tools.
This will be done in a single file, right? Terraform, a different file for Terraform, which we will be running. Then we'll running a different file of Ansible or Packer to make those changes inside that infra. That's not the case. Everything will be done in a
That
single
is,
file.
no. That is second one, because Terraform is meant only to manage. But what I am saying is Terraform can be invoked in such a way that this will call the other tools. That can happen. Or you can use a combination of both of them. Okay. So what you have to do, see, it's like a buffet. Okay. Now I can prepare separate dish and keep it, right? Like I can prepare my veg and I can prepare my non-veg, and as a buffet, I can put it together so that whoever wants to eat, they can eat a combination of this, or they can go to a desert and eat. But can I prepare both at the same time in one kadai, or in one set of vessel, veg and non-veg both, or dessert and this together? No. So this is how it
No.
is. To get your end result, you might have to create or modify a infra and then configure that infra, or you need to run something. So for that, you are going to use a combination of this. But for Terraform, it works in infrastructure as a code. For this, there is a separate syntax. If you want to call Ansible, there is a separate syntax. If you want to call Packer, separate syntax, and it has its own file. Same way, if you have Docker or Kubernetes, it has its own file. But as a combination, you can just call this. That means, like a buffet, I can take a large plate, put my veggies, and then I can go to non-veg and put something in non-veg. And I can also put a dessert and carry. It depends on what kind of plate I take, right? Same way, you can use Terraform to call Ansible or Packer or Docker, or as a workflow, you might call Terraform first and then call Ansible or any of this. So it's a complete way of how you're managing everything, which is your end-to-end solution. However, what we will see first is to understand how Terraform is going to work, and using Terraform, what is a method to call any other of tools. That's also something we will see.
Yes, I guess that's a lot. First, we'll need to learn Terraform syntax, and then we'll need to learn Ansible, Packer, and Kubernetes syntax.
Yeah, so we will not be covering these, but in fact, there was an ask to go through this just on high level, because these two are very closed packed. So because Terraform is again HashiCorp tool and Packer is also the same. So what we will do, we will focus completely into Terraform, wherein I'll give an overview of these on how you can use Terraform at the end to invoke Ansible or Packer or Docker. So that we can do. Okay.
Okay, sir. Okay, sir.
Any questions or doubts until now? Okay. Now, this completes your fundamentals, because without this, as we move forward, it will be difficult. But there are some concepts that we have to learn in Terraform. Okay. So we'll get more deeper into the core Terraform. But before that, any doubts until here? Or is it clear what you're trying to do?
No doubts
Okay.
as of now.
It's fine. Yeah, so I forgot to ask a question. So I hope everyone have your AWS account, so that whatever we are going to do, I want you guys to repeat the same. Okay. So I believe everyone has your own AWS account to do that. I think
Yes, sir.
whatever
We
you
do have.
AWS your training last week, you can kind of use the same. It should be good. All right, cool. So do you guys want a break?
Yes.
At least, can I hear it loud? If not, I'll continue.
Yeah, sir. 10 minutes break will do.
Yes, sir.
Yes, sir, for 10 minutes.
Yeah, at least for this you should answer. Chalo. Yeah, so do a favor, take a break, and we'll meet it by 10, 11:15, right? So 11:25 to 11:30. All right. Fine.
Yes, sir. So actually, when we had sessions in the last week, no, we were used to communicate via chat. So we don't have this habit of unmuting the mic, talking, and again muting the mic. I'm going again on the chat box, and then I'm remembering, okay, I can unmute the mic now. So that's the problem. Maybe most of the people are not giving immediate responses, or they might be giving on the chat box.
Yeah, but I didn't see anything in the chat, and I prefer to keep it more verbal because if it was a classroom, I know it's going to be interactive, but it's not able to find out what you guys are doing, but just to understand whether you're able to grasp because you keep doing a chat. In fact, I personally feel it will not be so well to communicate. So, it's nothing wrong. Just say whatever that you guys feel. If you're not getting anything, it's always easy for you guys also to understand, and even I will know. So that's the reason I prefer to keep it more interactive. Okay.
Yes, sir. This is
Anyway,
better.
that's fine. Yeah, take a break. I'll be on mute, and we'll just reconnect by 11:30. Yeah, I'll talk to you in 10 minutes. Hey guys, is everyone back? Hello?
So I'm back.
Yes, sir.
Yes, we have.
Yeah.
Okay. Fine. Probably we'll get started. So now we need to go into the fundamentals, okay? So we'll start step by step. So Terraform, we saw that there's some kind of code that we have to write. So Terraform basically is an open source tool which is developed by HashiCorp. Okay, now Terraform is also available in enterprise version and cloud version, but I believe in your organization you are using more of open source. So regardless of that, now since Terraform is being developed by HashiCorp, so the syntax or the code that we are going to write, the file that I was talking about, so typically that uses a language called HCL, which is HashiCorp configuration language. Okay. Now, a configuration file that you try to write in Terraform should always end with .tf. Optionally, you can also store it as a JSON, but ideally, all the file should be having the content in HCL, and you should store it as a .tf file. So a .tf represents it's a Terraform configuration. Okay. Now, there can be one file or there can be multiple files also. So remember that. So when you run Terraform, it will try to read all the TF files in your current directory, and based on that, it will do the plan or it will do the apply. So that way, you need to make sure that whatever the content that you want Terraform to read, it should be in a .tf file. Okay. Now here, the contents that you're going to write inside the TF file will be in blocks. So usually you'll be using the square bracket and open and close different blocks. So anything that you're going to define will be in separate blocks. So in fact, now if you say Terraform has to connect to AWS, then that should be in a block. And within that, you're going to define what are the different configurations for AWS. And in that, if you want to connect to AWS and create a machine, then for the machine, there will be one block. Suppose if you say, I want to create a security group, and for security group, there will be a block. So that way, everything will be in blocks. Okay. So you'll have separate blocks. And within the block, whatever the actual lines that you're going to give will be in a format of a key and a value pair. Okay, so this is where depending on what exactly you're going to do, you will be having the key names and the values will be appropriate to it. Okay, so remember, every line under your block within the flower brackets will be in a key and a value combination. And anytime in this language, if you want to comment, a single line will be commented using hash, and multiple lines can be commented using the backslash and the asterisk. Okay. Now, since it's a language by its own, you can also define variables in it. Okay. So whenever you are defining a variable, there are different types of variable, which we will see as we go through. But just to understand, now in your basic scripting or programming, so you have three types, right? So one is your default type, which will be your scalar value, which is a single value, okay, which is a normal string. But if you have multiple values, then we call them as an array, or we call it as list. Same way, when you have multiple values, you can also give a key and a value combination so that it's easy for retrieving. So those are called as maps, okay, or in certain other programs, you call it as hash. Okay, so this is somewhat similar to Python, where in Python, list is called, array is called as list, and a hash is called as a map. Okay, so these are the type, but the point here is when you're defining a list variable, that's the array, then you have to use square bracket. And when you're trying to define a map, then you're going to use a floor bracket. So we'll try to see this. And another thing is, on the older version of Terraform, to retrieve a variable, we were using dollar and floor bracket, and within that, you will be seeing var dot the variable name to retrieve. But however, on the latest version 13 and above, you don't have to do this. Okay, so you don't have to do the dollar and the floor bracket. Directly, if you say var dot the variable name, it will retrieve or return you the value. So these are just a high level syntax that you should be knowing. Okay, so as we move forward, we will repeat, but just remember, any configuration that you're going to give will be in a .tier, and Terraform will run on the current directory and pick up all the Terraform or all the files which end with .tier. Okay, so it's not just a single file. Okay, so with this basics, now when you open a Terraform configuration file or a TF file, I said there will be multiple blocks that you will have. Okay, so basically the types of blocks can be divided into 3 or 4 types. Okay, but as we go through, we will see that. But as a basic or a fundamental, the first block that you should be knowing is a provider block. So what is this block going to give? So this is the block which has the definition on the plugin or what is your service provider to which you want to connect. Okay, so that way here the provider block will be specifying whether you want to connect to AWS or Azure or GCP, or you want to do something on the same machine where you have to run Packer or Docker or Kubernetes, right? So that's what we call it as the plugins or the provider. So basically, provider block tells what plugins to use so that you know what is the service provider to which you have to connect. So every Terraform configuration file would have at least one provider to tell where you have to connect. Okay, and the syntax for this will be a keyword called provider and followed by the name of the provider. So this is what will be varying from what exactly you want to connect. So depending on your need, you have to find out the syntax and you should be replacing it. And within that, all the configurations that you have to do will be in a key and a value combination. So for example, if you're connecting to AWS, then you will say provider, the block name as AWS, which is the AWS provider. And within that, you will be saying your access key, your secret key, which region to connect, those kind of things you will be putting it together. Okay. Now, just be aware of it so that as we take some examples, you will know. So provider block will tell where to connect. And for that, what and all the configurations that it needs to know how to connect. Okay. So that is what is the provider block will be. But using a provider block, Terraform only can connect to a service provider. But the next important block, what we will have is a resource block. Okay, because to each and every service that you are trying to access in AWS, there will be a resource block specific to it. Okay, so this is where, if you go back to the diagram that I was showing you, so if you want to get that as your desired state, then you need one resource for managing VPC, one resource for security group, one resource for load balancer, and one resource for your machine, and one resource for your DB. Or within your load balancer itself, you might have things like auto scaling, and you might have launch configuration, right? So for each one of them, there will be separate resources. So if you open your Terraform file for this desired state, you might have one provider block which points to AWS, and after that you might have around 7-8 resource block where each one of them particularly points to a separate service in AWS. Okay, so remember, every service that you have in your AWS corresponds to one resource block. So that is how you give all the input to Terraform. Then the syntax for this will be, again, you have to start with a default keyword called resource, and following it, you're going to give one which is the type. So the type here indicates the provider and what type of resource that you want to use, because this again, for a particular type of service provider, the type of the resource will also change. For example, if you want to create a machine, so in AWS it is called as EC2, but if you go to Azure, that's called as VMs, right? So that way, now you need to find out in the provider, whatever that you have mentioned earlier, what are the resources that is going to be available. So based on that, you need to give this name. Okay, so this is the name, like a function which Terraform will know what it has to do. However, followed by this, you see a name here, right? So this name is a name which you give to identify this resource, and after Terraform has been creating, or when it does the plan or apply, it will be telling with this name. So then you will be able to identify, okay, if this is a machine, then you give some appropriate name like AWS machine for some project or something like that. So you will know what resource Terraform is handling and what it is trying to do. So this is what it will take, that I'm going to create this resource, or I'm going to delete this resource, or modify this resource. So that way, the name here, what you give is your option, a user defined. This is just for Terraform to refer to what you mean here. Whereas this is what you need to know, what are the providers available, and for that particular provider, like for AWS, what are the different types of resources available to manage different services. Okay, so for example, AWS is what we know provider, and the type here will be instance. Suppose if I want to create a machine, then the block will look something like resource space AWS underscore instance space. I can give any name that I want. Okay, so I can give it like my own example or demo, something like that. And within that, what you will have, so you will be having keys and value, and the key is nothing but you are going to have the details, like for a machine, what and all you need. You have to tell the AMI ID and which VPC and what type of machine, which CPU, how much of RAM that you need, what security groups to allocate, what will be the key. So those will be defined as a key and a value. Okay, so remember, these are the two primary blocks that you need for your definition. Okay, and whatever that you give, you will be putting it up in a .tf file. All right, now just remember this much. Now as we go further, we'll try to take different examples. Okay, now the first thing that we need to do is we need to set up Terraform. And as I said before the break, all you need is take one machine and you can install Terraform, and that is what we call it as the Terraform core. And you don't have any dependency of it. Okay, you just take a machine and install Terraform, as simple as that. Now, if you want the latest version of Terraform to be automatically installed, then what you can do, you can simply download the latest version and then you can just install as a service. Now, I'm going to take Ubuntu because of one reason. It's very simple and straightforward. Now, depending on your organization, you have to find out what is the OS finally you're going to use. But for practicing, Ubuntu will be very straightforward. Okay, so either I can take the latest, or if you're interested for a particular version of Terraform that your organization supports, because what happens, the syntax changes a little bit from version to version, and there are some options also which is available only on the latest version. Or sometimes if your company is still under a particular older version, then you should be able to install only that. So what you can do is, if you have a specific requirement to install a particular version, then what you can do is you can you can download the archive of a particular version and then extract it. Okay, so that way it's completely up to us to choose what version we need. Now the most recent is 14, but that involves a lot of new things to know, and again, a lot of configuration changes. So, but I'm not sure which version, but as a standard version, organization might be using 12, which is one of the latest, or they would have moved to 13. So what we will do, we'll try to install 13 for some time, and as we move forward, we can go to 14 also, because 13 and 14 almost works the same. There is no much differences. Okay. Now for this, I need a machine. So what I need to do first is, let me create a machine in AWS. Okay. So this is where I have my own account. All right. So let me connect. OG. Okay, I'll create a new machine. Now I'm going to use everything default here. Okay, so I'll take Ubuntu. So I'm taking Ubuntu 20, which is the latest. And for this T2 micro should be more than enough. Okay, so I'm just taking the default one. And I just need one machine, and I'm leaving everything to default. So that's the default VPC, and the subnets will be there. And yeah, storage is also nothing needed for Terraform because it's just a file. And yeah, so I will add this to an existing security group, because this is where I have a couple of default ports like port 80, okay, and port 443, port 22 for your SSH. So these are some of the default things I have. So I just leave it to this. Okay, now just create, and there's a master key. Okay, so this is what is the name of my key that I use. Okay. Okay, so you're gonna get this machine here. It's coming up. Okay, I'll just mark this as Terraform. All right. Fine. So let's connect to this machine. So I'm just going to use the same native way of SSH. I don't want to convert the key. So I have a command prompt. Again, if you're using Windows, you can use any of the terminal prompts that you have, or I use generally git bash, wherein you can get both the Windows and the Linux. Or if you have putty, I think if that's what you guys have used for your practice, then you can use the same to connect. But here I'm just going to use this because the screen is good for you guys to know. So now this is a Ubuntu machine. Okay, Ubuntu 20, and I'm just switching the user as root. So what I'll do, so I'll just go ahead and install. Okay, now for this, what I'll do, let me just change this 11 to 13. Okay, so I'm going to download the 13th version of Terraform, which is a zip file. So you should get this file. Now, sometimes you might not have Unzip available. Okay, so it says it doesn't know. So go ahead and install Unzip. And this is where either I have to run everything using the sudo option, or I'm just kind of switching the user to root. So the very first thing what I did was sudo su. Okay, so do a sudo su so that from the Ubuntu user you're switching to the user called root, and as that user now I have installed zip. Now using this unzip, I'll just extract. Okay, and while I'm extracting, you would get a Terraform executable that I'm directly putting it to user local bin. So you can put it to any location which the path variable refers. Okay, because in Linux or in Windows, you have path variable, because anytime you run some command, it will check for the path anywhere inside this. If it is available, your command will be executed. If not, it will say command not found. So hence what I did, I extracted Terraform to a folder which is already available in my path. So you can put it to anywhere also. It's also fine. So now here, if I just say which Terraform, you can see Terraform is available under user local bin. So now if I just execute Terraform, you should be able to see that you have Terraform available on your path and you're able to get it. Okay, so this is the first thing. Okay, so now the question here is, how do I share this? Okay, this is the question that I was asking. You guys are not familiar with Git, right?
Previously, we used Git, the Sheets, Google Sheets.
Yeah, I have to create that, and yeah, I know. Then I need to add from my email to all you guys so that I keep updating here. You'll be able to see that. Okay, so let me do that a little later in the break. But for now, I'll put this in your chat box. You can take this in. Okay. So quickly, can you go ahead and install this?
Sir, can you please give a short overview of what you did after creating a server? Things went so fast that I'm not able to recollect everything. And also, sir, for one of our team members, her mic is not working. Surbi, her name is Surbi, so she will be using chat. She said that during the break. So if
That's
it is
okay.
fine, can you please give an overview of what you did after creating the server?
Okay, so like I said, Terraform just needs one machine in which you need to install Terraform. So there are different ways to install Terraform. Now, either you can install the latest version using this command, wherein directly it will be downloading the latest version from the repository. But what will happen now here is, I want to install a particular version. So this is where what I need to do is, I need to download a particular version of Terraform archive and then extract. And these are the steps for that. Okay. Now, assuming that we are going to work on 13, then what I did is, I need to first download this file and then extract this file. But for this, you cannot do it as a regular user, because when you say unzip, if this is not available, you need to install Unzip first on the machine. But for all these things, you need the privilege as a root privilege, or you need to prefix sudo in front of everything. Okay. Now, instead of that, so what I did first was I changed the user to root by saying sudo su. So as soon as you log in, okay, so this is how you would have been logged in, wherein the user as sudo. Now as this user, if I just try to run this command, you will get an error, because as normal user, you don't have the access. So what I did was, I did sudo su and I switched to the user called root. So now, since you are switching the user as root, you have all the privileges. And in this, what I did, I first downloaded the 13th version of Terraform zip file, and that I unzipped. When I extracted it, I directly put the file into this folder because this is one of the folder which is available in the Linux path variable, so that once you have extracted, if I type Terraform, it can easily identify. So if you don't extract this to any of the path variable, then you have to explicitly add the path variable to the location where you have extracted. And this is what I have done.
Yes, sir. Okay.
Can you try quickly?
Yes, sir.
Okay. So Adam, first we'll need to create an Ubuntu server on AWS, and that we'll need to install this, right?
Yes, so you need a machine for running Terraform. So basically, this is the Terraform core that I was telling. So go ahead, create a Ubuntu machine, and in that machine, try to install Terraform.
So what
Okay.
software did you use to connect that machine? The terminal came open up. We'll be using Mobax term. Will it be fine? Because we had been
And
using
that's what
that
I
for
was
the
trying to
SSH
say.
client.
Whatever that you guys did in your AWS, you follow. So I'm just using a simple command prompt. So this is a git command prompt, okay, or what we call it as git bash. It's just a normal command prompt. But
Oh,
when you
but
install git
how
on
did that?
Windows, that's what, when you install git on Windows, it gives you a command prompt where it is a normal command prompt. Okay, so whatever is there on my desktop or on my Windows, this is what you have. But this is not like a normal Windows command prompt. See, this is a Windows command prompt. Here I cannot run all my Linux commands because SSH is also not available. So this is where when you install Git on your laptop, in Windows, it additionally gives one more command prompt called git bash. In this, all your basic Linux commands can work. So that is where instead of taking the PEM file and converting it into a key and then connecting, I directly use this command prompt and I run my SSH command directly, that whatever you get here, right? So this command that I will run. So that is what I did. So what I did is I have already downloaded the master PEM file into one location, because in Windows, whatever you download, what will happen? It will always go to your downloads folder, right? So I went to downloads, and here you have the master.pem, and from this location, I just entered this command. So from my machine, I'm telling use this PEM and connect to this machine, which is what we created as a user called Ubuntu. Okay, and there you go, it's connected. And this is what I did on the other screen. Now, instead of you doing it, I'm saying you connect to the machine to whatever method that you have learned earlier. If you want, this is just a simple way. Okay, if you want to do it, probably install Git for Windows. And once you install Git for Windows, you will be getting this git bash command prompt additionally. Got that?
Yes, sir.
Can we just install Terraform on a local system?
You can do, but there are a lot of things that from when you say your machine, you need to know the network is available, right? So there will be some issues that you can do, because in an organization, always you will be using it within a network where you're going to manage. So for practicing also, it will be different. So rather than debugging those issues, it's good that if you quickly create a machine in AWS, because anyway, you're going to do that. Okay, so create a machine and install Terraform.
Okay.
I'm done with the installation.
Awesome. Yeah, let's just give some time for others.
Sir, downloading done.
Yeah, sure, take your time. But let me know if you have completed.
Sir, done, sir, downloading.
Okay, so you're able to run Terraform, right? And if you just try to run version, you should get that output.
Yes, sir. Yes, sir.
Okay, cool. All right, so what we have done is our basic setup. Okay,
Yes, sir, it's done.
all right. Now, before we go to the commands, okay, so let's take a simple example and we will see what, how Terraform works, even before going into the AWS. As I said, you can use Terraform to basically connect to any service provider and you can tell the infrastructure what you need. Okay, so whether it could be AWS or Docker or Azure, everything is the same. Now, in the first example, I'll just quickly show you what Terraform can do. Now, assume I want Terraform to connect to a machine and help me to create an image. Okay. Now, this way I'm talking about a Docker image because the way that I want you to think is Terraform is not purely meant for only using to connect against AWS because there are a lot of other things. But regardless of that, when you say Terraform has to connect to a service provider, then you need to provide a block called provider block. Okay. Now, what I want is I want Terraform to basically connect or communicate to Docker and help me to download an image. Okay, so that is what I'm looking at as the first example. So for this, what I will do now, I want to make sure first my machine has Docker also available. So preferably for this example, what we will do, we'll say apt install, before that, apt update, apt install -y docker.io. Okay, so I want you to just enter this. So what this will do, this will update the OS on the machine and it will install Docker. Again, here we are trying to use the same machine in which the Terraform core is there, but in real time, you might have to connect to some other machine. So that's the only difference that you will do. But for the ease of practice, just go ahead and run this on the same machine as the root user. Because once again, when you do apt update and apt install, you will not permission for other users to run. Okay. So I'll go back to this machine and as root, I'm going to just enter this. Okay. So go ahead and run this also.
Adam, can you just wait for some time? Actually, we are trying to still install it.
Okay. And that's what I've been asking because unless you guys don't tell me, it's a difficulty here, right? So feel free to say that if you need time. Yeah, go ahead
Yes.
and run this. This I've already pasted in the chat.
Hello, Adam.
Yes.
Yes. Do you have any idea about how to connect on Mobax then?
No, I need to see. So how did you guys connect to AWS machines?
Actually, for this Linux servers, what we did was we just entered the remote public IP, and then we selected this file, the key file, PEM file, and then once the session we connected to the session,
Yeah,
there
from where
we
did you run that?
from Mobax only mostly.
Yeah, can you do the same now?
Yeah, I'm doing the same. It's just that when we log into that, first we get the option to log in as a user. So what we
So
did was
the
on the
user, EC2 user or Ubuntu?
The user here is Ubuntu because I'm using Ubuntu machine. The username will be
Yeah.
Ubuntu. Hey, those who have, I'm not familiar with the other tools that you are using, or I don't know how you guys connected. For those who have connected, can you just help the person?
Yeah,
But I'm not able.
so the user will be Ubuntu. So we were using the Amazon Linux, so it was having
Okay,
EC2
EC2.
user.
Yeah.
Yeah.
Yeah, here we will be using the user as Ubuntu.
okay, thanks. But I'll just try and inform you once I'm done.
Sure. Others, you can just go ahead and install Docker.
Done, sir.
Okay.
Yes, sir, it's done.
Okay, anyone who's still installing Terraform?
Yeah, wait, I'm still installing.
What about other people? Kajal, Nitish, Rahul, Sanal, Shrishel, Shubham.
Still trying to connect, sir.
Sir, I'm done. Sure.
Okay.
Rahul done.
Shrishel done.
Others, Humera.
You're done.
Sir, Nitesh done.
Yeah, please call me Adam, guys. You're more into corporate now.
Yes, I'm done. I'm Sanal here.
Okay, cool. So now, once you have completed this, now to check whether Docker is running or not, just enter the command called docker info. Okay, docker space info. And you should see some huge output. Okay, so if you get this, this means Docker is also installed. Okay. Are you able to see this output when you say docker info?
Yes.
Yes.
Yes, sir.
Okay, cool. So what we will do now is to take the very first example. Now remember, in Terraform, as I said, there are going to be multiple configuration files, and it's always advisable to create a separate folder for different state that you want to tell. That means, like, even when I'm doing an example, I'll be doing different things. So it's not that I can do everything into one folder. Same way, when you have one state, for that, if you have one file or multiple files, put everything together as a separate folder. So I'll tell you why that is needed. So in that way, now, so you might be working in some folder. So what I want you to do is create a folder. Okay, now give any name that you want. So what I'll do, the first one, I'll create a folder called Docker. And again, there's no preference on why I'm giving, it's just to understand that I'm going to show you an example of Docker. Okay, so what I'm doing is I'm creating a folder called Docker and I'm going inside it. And this is where I'm going to create the file. Okay, so please do create a folder, and as you watch it, for every example I'd be creating a separate folder, because we have a concept called state, which you need to understand later, for which you cannot run everything into the same file, same folder. Okay, so now for this example, what I did is I created a folder. Now we are going to create a file which should end with .tf. Now, preferably, the name can be anything, but always try to give the name of the file as main.tf for now. Okay, because again, why do we need to give it as main? Why not others? We will come to know a little later. But until we go to that level, I want you to create all the file name as main.tf. Okay, so this is my configuration file where you are going to give the details. Now, what is that we are trying to achieve? So we want Terraform to connect to Docker and download an image. That's what we want. Now, this is where the first thing that we have to give is the provider block. Okay, so why do we need a provider? Because provider block is the one which tells Terraform on what is that particular service to which we want Terraform to connect. Okay, now if you have Docker running on any remote machine, then you can use any of this method to give the details on how to connect to that machine, because Terraform is running on your machine, and if you want Terraform to connect to some other machine to refer to where the Docker is running, so you can use the SSH method through the port 22, or when you run Docker, actually it runs on a port called 2376. So basically, you can also refer this. But to keep the ease of practice, we have installed Docker in the same machine. So all you have to do is you have to refer to a file, which is what internally is a socket. So Docker will be running or listening on this file. So if you give this, the Terraform will be able to communicate to the Docker, which is running, or the Docker daemon, which is running on your same machine. So this is an example of how do you give provider, wherein the Docker is a keyword which is given by Terraform. Okay, so you cannot choose any name for this. So provider has to be specifically what Terraform has the syntax. And within this, for this provider, the only thing that I need to tell is what is the host in which my Docker is running. Okay. Now I need this example so that you understand first the workflow, and then we will go to AWS so that it will be easy. Next, this is for connecting, but what is that you want to define as the state? So this is where we are not yet going to creating a machine or other things, but using the Docker, I want Terraform to help me download an image. So that way, my desired state on this machine, whatever that I'm going to run. So I'm saying, Terraform, connect to this machine, and I want to make sure there is an image available. That is what we are saying. Now that's when, for working on an image, for Docker provider, there are different resources. So one of the resource what we need is a image. So this is where, once again, you need to specifically have a separate resource block for this, where you have the keyword which is standard. And what is this? So this is again standard because this is specific to your provider. So you are saying the provider name underscore the type of resource using this provider, what you want to do. And then you are trying to tell the name of this block, so that once you run, you will be able to see what Terraform is trying to do. Okay. And for this image block, what is the name of the image which you want to actually download? And that is what you are giving the details. Now I just have one example of resource block. Okay. Now, if you try to say Terraform and run, it will connect to this Docker and it will make sure that there is one resource created. If it is not available, Terraform knows from where to download it. And at the same time, if it's already available, it will say your infra is up to date. Okay. So now, if I have to run, then this is where make sure you have a separate folder. Okay. So here I'll create the main.tf. Okay. And enter this. Okay. Now, for this specific example, what will happen is the 13th version of Terraform is still outdated because these are available only on the latest version. So only for this example, what I want you to do is run this command additionally. Okay, this is not for all the other case. So what I'm trying to tell now is you're just trying to tell to upgrade the 13th version with any kind of patches, whatever is available on top of that. Okay, so that the syntax for Terraform will still use 13, but it will be trying to take certain latest libraries or plugins which is needed for this kind of provider block. Okay, so make sure first you run this. Okay. All right, so you don't have to do it again. It's just a one-time activity. All right. Now this is nowhere related to your day-to-day workflow or whatever it is. It's only for this provider, which I said on top of 13, you're just kind of upgrade. Again, it's just one of the scenario where later also you might have to do sometimes when the provider blocks are not there. So if you want, before doing this, okay, we will run some of the commands and see this will not work. So it will ask you to first do an upgrade. So that way we're just making sure the upgrade is done. Okay, so what is that we have done? We have created a new folder. We have put our configuration file, which is main.tf, in which there is one provider block, and related to it, we are telling one resource block, which is the state. Okay. Now, how do you run Terraform?
Can you add this in the chat box?
Okay.
The file actually.
I'll give it to you because before that, I want you to see what is there. Okay, I'll share it.
Oh, okay. Okay.
Don't run when I'm explaining, because if you do that, you will be missing what I'm doing. Okay, so I want you to basically run post what I do. So here,
First you connected Terraform to Docker by providing provider, provide name, and host. But from
we
where
haven't
this
connected.
docker.sock came in?
No, that's what I'm trying to tell. We haven't told anything to run. So basically, we
No,
are trying to tell. That is what I'm trying to explain. What do you mean by provider? Provider means we are telling, hey, I want you to connect to Docker. That is what you are telling. But where is that Docker running? Correct? See, an example I can take AWS, but where is AWS? What is the username and password that you need to use to connect to it? So you have to give it within the block. So that way, when you're telling to Terraform to connect to Docker, in which machine the Docker is running. So that is where here, if you install Docker on the same machine, you will be having a file called where run docker.sock. This is where the Docker daemon or the process will be listening. So if you give this path, the Terraform will be directly communicating to the Docker daemon on the same machine. Okay, so that is what is the meaning that you say directly refer to this file. Suppose if it was on a different machine, so this is where I was showing you a couple of other options where you have to do the SSH method or the TCP method and give the details of the machine where you are running. But since we have Docker installed on the same machine, all I'm telling to Terraform is go to current machine, and in the current machine there will be a file. You just listen to this file. Internally Docker is also going to listen. That means anything that you handle in this, you are handling the Docker daemon on the same machine. Getting it?
Yes, sir.
So docker.sock is basically present in a system when we install the Docker, right? This
Yes,
file.
it will be available
So,
on your same.
so if in case of Windows system, like the host will be TCP, right?
Yes, so that's where the connection method will be different.
Okay. And the path will be what we have to do. Correct. Got it.
Yeah, so that's the reason I don't want you to run anything on your Windows, right? Because there's a lot of configurations that you might have to do on Windows. So preferably Ubuntu will be very simple.
Okay.
Okay, so now, so we have told the provider block, and this is the resource what we need. Okay, but what is that we have to do next? So we have to start running Terraform. Okay, but for that we need the commands or the workflow. Okay, so this is where the workflow of Terraform we will see now. Now let's not worry about what is our configuration because this would change, but what is the workflow? So the first thing that you have to do is you're going to say Terraform init, because going forward, you're going to call Terraform and pass a option or an argument. So what do you mean by Terraform init? So any configuration file that you have, it needs to be initialized first. Okay. So what do you mean by initializing? Initializing means with respect to the provider that you have told, Terraform will try to download the plugin to run this first. So whether it is Docker or AWS or Azure, it has to first download the plugins which is needed to connect to Docker or to AWS. And that is what will happen when you say Terraform init. And remember, this is something which is needed only at the very beginning when you have created a new folder, and in that folder you don't have anything else other than your main.tf. So you should go ahead and just execute Terraform init. Okay, so when you say Terraform init, it will try to download the plugins needed related to the provider. Okay, now if you go back to this folder, forget about this versions.tf because this is the one which got created while we set the Terraform upgrade. But other than that, if you look, there is no other file or folder in your current folder. Now, for the first time, when you say Terraform init, you can see what it does is initialization, wherein it's trying to download the latest version of the Docker provider or plugin which is needed, and that is available on your current machine. So going forward, in this folder, if you try to run Terraform, it knows that it has to connect to this particular service provider. Okay. Now, what is the difference? So if you now look at this folder, you would have seen that there is a new folder called .terraform. It's a hidden folder. And what does this contain? So if you go into .terraform, okay, so you would see that it has plugins folder and it internally has a lot of other folders and files, wherein here it has the Docker plugin. Okay, you can see this is what it has. So this is the plugin or the provider which it has downloaded. So to run your configurations from this folder, it has created a .terraform folder, and inside that it has downloaded the plugin. Okay, so this is where one of the reason you should have a separate folder for every configurations that you want to run. Okay, so again, this is just a one-time activity, and whenever you are adding a new provider or whenever you are customizing the provider or plugin, then you need to run the init. But if not, most of the cases, 99%, you will not be doing the init again. So it is just the first time on the folder where you have copied this file. So once you have done the Terraform init and you have the initialization done, the next thing what you're going to do is Terraform plan. Okay, but before that, you can actually do a Terraform validate and find out whether is there any syntax issue in your file, whether the blocks has been defined properly. So that is what you're going to do in Terraform validate. Okay, so now this is where after you modify the configuration files as we move forward, as a best practice, the first thing you're going to do is Terraform validate. So here it says your syntax is fine. Okay, so once you have validated your syntax, then you're going to say Terraform plan. Okay, so what does plan do? So as I said in the beginning, now you are telling your desired state, and it will try to take your desired state and it will check the current state. Is there any difference? And if there is a difference, what is it going to do to bring this desired state? Okay, so in our case, we are trying to make sure that there is an image downloaded and it is available. And if it is not available, what exactly it is going to do? That is what the plan will be. Okay, so now watch this. When you say Terraform plan, okay, you might have to stop and see this output. So it's trying to refresh the state, and here, whenever you get the Terraform plan, okay, so there are three things that it will do. One is create. So any resource that it is trying to create, it will indicate a plus. Suppose if there is a resource which it is going to delete or destroy, then you would see a minus there. And in case if you are seeing a resource which will get updated, then you will see a tilde mark. Tilde means you will get this. So plus for creation, minus for destroy, and tilde for update. Okay, so based on this, you should know, okay, what it is trying to do. And this is where you can see it is trying to tell you this is the resource block which it is going to create. Okay, and sometimes if it has to recreate, then you will see a plus slash minus. That means it is going to delete and recreate the resource. Okay, so that way for some time you should see a combination of these two. You should see something like this for recreate. Okay, so based on that you will know what exactly it is going to do. All right, so right now you can see it says there is only one resource which is going to get added or created. There is nothing to modify, there is nothing to destroy. Okay, now here, once you have done this, and now you have seen, okay, it is going to create a resource, and this is where you are going to say Terraform apply. Okay, so what will apply do? So apply will typically take the plan's output, and it knows what and all it has planned. So based on that, it is going to exactly update your provider by connecting and bringing the state what you need. So this way, right now, just to show you, if I say Docker images, so there is no images available. Okay, but what we will do now is if I say Terraform apply, now when you say Terraform apply, it will prompt us to enter yes or no to proceed further, because you are going to change your infrastructure, right? Because in production, assume you are doing by mistake, you just say apply and it just goes ahead and changes everything. So you have a way to verify. So here, only if you say yes, it will proceed further. Okay. Now, in case if you don't feel to be prompting, if you want to ignore this prompt, what you can do is when you say apply, you can say auto approve. Okay, so it will not ask us to enter. So what is that now Terraform has done? So now you can see Terraform has connected to the Docker on the same machine and it has created the resource. Okay, and this is the output of it. Now at this level, if I say Docker images once again, and you can see the ID, whatever the image has been created, it is the same ID which you are seeing. So Terraform now has created this image or downloaded this image for us. Okay. So apply did create this. So this is not the fun. So now, what if I say Terraform plan again? Okay, so at this level, I have not changed any code. But if I say Terraform plan, so it should clearly say that what is your desired state. So your desired state is you want one Docker image to be downloaded and available. And that is already available on your machine, and this is the ID. So it clearly says that your state is already up to date. So there is nothing that needs to be changed. Okay, so this is how Terraform compares the state and it will be deciding in the plan. Now, even if you go ahead and forcibly do a Terraform apply, it will not do anything because in the plan, there is no change. Only when if it finds that there is a change in the plan, this will be going ahead and applying. If not, it will not apply. Okay, so even if you go and say Terraform apply, now I can just say auto approve. So nothing to be done. Why? Because in the plan, there was nothing it has found out. So apply will also not do anything. So this is where every time when you say plan and apply, based on the plan, it will apply. And it doesn't have to do again because this is where you're trying to tell this as a declarative method. So you're not telling what to do or how to do or what command to use to Docker to download. Internally, using the provider and the resource block, Terraform will be managing. Okay. Now, so we saw how do we plan and how do we apply, but any point of time, if you want to see the properties of the resource block, what it is managing. So for that, you're going to say Terraform show. So in our current case, it is managing one image, right? So basically, if you say Terraform show, you should see that this is the property of the resource block which Terraform is managing. And this is how it knows that this is the image ID which Terraform downloaded, and that is what is currently available in the machine. Okay, so it goes ahead and keeps a track of this. So anytime if you want to see what and all are the resources and its properties which Terraform is managing, use Terraform show. Okay, and finally, if you do not want the entire infrastructure what you have just defined, then just go ahead and say Terraform destroy. Okay, so destroy means the opposite of apply. It will delete whatever that you have told. So here we have told I need one image, so this image will get destroyed. So watch it. Now you can see it is trying to say destroy, so hyphen, and it is telling this is the image which will destroy with the ID, and it is going to ask for a confirmation. Okay, so only if you say yes, it is going to delete it. And now if I say Docker images, you don't see anything available. Okay, and now if I say Terraform plan, it will clearly say I have to create a resource. Okay, so watch this. So this time if I say Terraform plan, So now clearly it says that I need it. Okay. And once again, if I say Terraform apply, so it will go ahead and create. Okay. So once again, if you say Terraform plan, there's going to be nothing. Okay. So this is what is your workflow. Okay. So you're going to say first, or the very beginning, you're going to say init, that's all. But after that, whenever you modify a file, you're going to say validate, and then you will plan to see what is happening based on your change to bring the desired state, and then you apply, and at any point of time you want to see, you will see Terraform show. And destroy, you should be very careful to use, because in production you might not do, but for practicing it's okay. But destroy will remove everything that is the opposite of the state what you are trying to tell. Okay. Now, so here when I say Terraform plan, nothing, because it's already downloaded the image. Now just to extend this in the workflow, what we will do, we'll try to add another resource. Okay. Or basically I'll try to modify the image and I'll show you what will happen. So here, okay. Now if you take this, now when you take an image, now an image has various versions. So what we are taking is latest. So what I'll do in this example, probably we will take an older version of the image. Okay. And then we'll see what happens. So what I'll do, I'll edit the main.tf, and instead of the keyword called latest, I'll just change this. So let's say CentOS 7.0. So hope this is there. Now let's run this. Okay, so what I've done, the existing resource I just modified, and now here we should follow the process. Terraform validate. Okay, Terraform plan, and now you can see what is happening. It is updating. So there is a resource already that it is managing, but for that, earlier it was CentOS latest, but now you're trying to say CentOS 7. So it is updating. Okay, so it doesn't have to do anything, it's basically updating, and that is where you will also see the resource being changed. And if I go ahead and say Terraform apply, so what this will do, this will basically now try to download a new image based on CentOS 7. Okay, and okay, so looks like there is nothing called as CentOS 7. So quickly to cross check that, what I'll do, I'll go to Docker Hub. We'll just find out what version they have. CentOS. Go to tags. Okay, so they just have only 7. The name is not .0. Okay, so what I'll do, we'll just go ahead, update this only to 7. So the name or the version is only 7. Okay, so quickly, Terraform validate, Terraform plan, and right now, okay, looks like the previous one got corrupted, but anyway. So now if I say Terraform apply, so it's going ahead and updating it. Okay, so since the last time what happened, while downloading, it felt that there was an error and it already assumed that it is updated. So that is where it was trying to create it as a new resource. Okay, so but right now you can see from here, earlier this was the image ID, right? So it is replacing this image ID with 8652. So if you now say Docker images, you should see two images. One is CentOS 7, the other one is CentOS latest. And what is Terraform maintaining now? Terraform is maintaining the latest, which is what you have given, CentOS 7. And once again, if you say Terraform plan, it will say nothing is needed. Why? It is up to date. What you want in the desired state, you have given it as the CentOS 7. Now, if I go ahead and delete this image, okay, I'm going to delete the first image, okay, but still I have the CentOS 7. And if you run the Terraform plan, it's saying everything is fine. That is because on your configuration file, you have told the desired state is to have CentOS 7, and that is what it is tracking, and that is what it's also available. So it doesn't matter if you delete anything else. So Terraform is bothered only about this. So just in case if this gets deleted, when you run plan, it clearly tell you again that that resource is not available. Okay, so that is how, if you go ahead and say, now there is no images, right? And this time, if you run Terraform plan, this will again tell you that there is no such resources I have to create. Okay, so this is where Terraform will be exactly comparing the state, and for that, it is going to basically check what is your desired state and what is the current state, and accordingly, it will be trying to say whether to create a resource or not to create. But ideally, once it is created, if you rerun, it will say nothing to do because it's already available, or it's the same state what you want to refer. Okay, and if you do not want, then all you're going to do is Terraform destroy. Okay, so this is the basic workflow of Terraform. Okay, so I want you guys to first get familiarized with this and see what and all is changing, what is not changing. And this is where I wanted you to start with Docker, because every time you connect to AWS, create a machine, stop and delete it, it will take a lot of time. But this is just kind of seconds you will be able to do. Okay, so I'll paste this. I think this is already there. So can you just try running this against your example and see how it is going to work? Can
So
everyone quickly
basically
try
what
this?
Terraform is doing in this example is just downloading a CentOS file which we are mentioning in the main.tf, and it makes sure that the file is there inside that folder. If it gets deleted or if it gets corrupt, and if we run plan, it will again get downloaded.
That's a small correction. This is not a file. This is an image which is going to be downloaded in the machine, not on your current folder. Okay, so it is available somewhere in the
Okay.
machine. Let's not worry about Docker. Okay, so you're just telling download the image and keep it.
So
If it is not there,
we
it
are
will
installing
download.
the image.
No, we are not installing. It's just called as downloading.
Okay. So an init command works only if the file name is main.tf.
Not like that. Okay, so
Okay.
when you run Terraform, any of the command, it will read all the files ending with .tf.
TF.
This is what the first thing I told. But out of
Right.
that, in our current folder, how many TF files we have? So basically now I have one file called version.tf. Now what does this contain? If you see, this just contains the information to tell that we are using this particular provider which is needed for this example. But other than that, you ignore this. So what you have is the only the main.tf. But however, as we go forward, we will see if I need multiple TF files, we will put. But if not, the logic is whenever you run Terraform, it will read all the TF file and decides. But why exactly I gave main.tf, we will see it a little later. But right now, it's just a best practice, start using it.
Okay, Adam.
So Adam, when you replaced that CentOS latest with the CentOS version, what did it actually do? Did it just delete the previous version and add the 7 CentOS 7 on in the place of it, or what?
No,
Or
it
did it?
didn't delete. So if you had seen, it was saying it as update, right? It didn't delete. So what did I do? Now again, I can do the same thing quickly. Now that's what, it depends on service to service. So here, once again, if I make this latest Terraform plan, so right now you can see it's not deleting, right? So it's just updating. So that way your CentOS 7 will be there, but it will just try to download the latest version and keep that also as a copy. So when I say Terraform apply, it's just refreshing the state of what it is tracking. So earlier it was tracking CentOS 7. Now it will download CentOS latest, and that will tell this is your desired state. So if you go back and see Docker images, along with the 7, it also has the CentOS latest. But this is what you are currently tracking, because on your configuration file, this is what you are telling to be your current state. So all it does is that this is where you will be able to see for what are the services it is going to recreate, or for few services it will just update.
So you
So
will basically have both the images.
yeah, machine has both of them, but what is that Terraform tracking, or what is the state you have told? You have told the latest, because this is what is available in the file.
Okay, it will track on.
Yeah, it will track only that. That is where I showed
Okay.
you that if I delete the other image, Terraform doesn't care, because what is that currently? Because see, you're telling the state is you want CentOS latest. So now it will make sure CentOS latest is available. That is what Terraform is meant for. It doesn't care whether the others are there or not there. So like this, for every configuration, you have to give different set of folder and give the files. So right now my interest is to make sure CentOS latest is available. So it will make sure only that, right? So now if I just say Docker or my CentOS 7, it will delete. But still, if I run my plan, it will say nothing. Why? What you have told is CentOS latest, and that CentOS latest image is available. So that's how it is tracking what you have told as a desired state.
Okay. Got it. Thanks. And one more thing, suppose like along with Docker, I also have VMware, and I also want to like create some resources on it. So can I just add that provider and
Yeah, yeah.
coding file?
We'll see that
Or
as we go forward.
okay, okay,
I'll
okay,
show you. I'll show you. So I'm
okay.
stopping it now just to make you comfortable with this level. Then we will add. See, that's a difference. We cannot just add everything and go. You will not understand. So I'm just walking you
Okay.
through step by
Yeah, no
step. So
problem.
first understand this: what is provider, what is resource, and what is the workflow on how Terraform is managing. Then we will add more resources, more concepts to this, and then we will understand. Because if you're strong, then the remainings will be easy for you. So I want you to, that's the reason, play around with this, run this, change this values, and then just try to rerun and see how it is happening.
Okay, sure. Thanks. Hello, Adam. Where do we have to run this Terraform upgrade command? Into the Docker folder, right?
Anywhere you run, it doesn't matter. It's better you run from the same folder.
Okay, because I'm trying to run it into the Docker folder, Terraform 0.13 upgrade, right? So it says not a module directory.
Say
Given
space
the
dot
it's
dot.
space dot. Okay, okay, okay. It's still the same thing. Space dot.
Tried it?
Yes, Adam, it's working. All the commands are working.
Yeah, cool. What about others? Able to understand the workflow?
What is the command to check
Yes,
the
sir.
Docker images?
Sorry?
The command to check the Docker images.
Docker images, okay. Docker images only. Docker space
Acha,
images.
okay.
Is everyone able to run this workflow?
Yes, able to run the workflow.
Okay. Now, just to add one more to this, so we know this workflow. Now, this is not going to change going forward. But the only thing is what we are doing here. Now, in this example, we just have one resource to download an image. And this is where the whole purpose of Docker is to create what we call it as a virtual environment. It's not a VM, but a small virtual environment, which is what we call it as container. So using this image, instead of creating a huge VM, you can simply create a small environment, which will be easy for us to start, stop, or delete, whatever that you want to do. Okay, so for example, on my Ubuntu, so this is Ubuntu machine. Now, how do I get a CentOS machine? Now, if that's the case, I should install hypervisor like VMware and then try to download a CentOS full image, ISO file, and then from that I should create a VM or a machine which will be acting as a CentOS machine for me. So instead of all these things, the whole purpose of Docker is we would be simply creating a small virtual environment using this image, which is very lightweight and it's easy for us to handle. So that is the whole concept of containers or Docker is going to come into the picture. Okay. So now for doing some small demo, now what I want is to get a environment which is having CentOS in it, not a complete VM. Now for that, we have downloaded. So we can just go ahead and add one more resource, which is what we call it as a container resource. So in that, we can also make sure that what is that you want to create. So typically what I'll do now, to the same source, whatever that we had the resources, right? Now for the same block, I can just quickly add one more resource block, which is called as Docker container. Like Docker image, this is a resource block. And for this resource block, we are trying to tell two things. One is, what is the name of this resource? So I'm calling it as my container. Like how I said my image, I'm telling this is my container. And the name of this, okay? So I'll just say test CentOS. And then what is the image that I'm going to take? Okay, now don't worry about this. I'll talk about it a little later. But for now, I'm just saying I need an image. Okay, and now if you run this by adding this into your configuration file, so there is a new resource that you're adding. So what will Terraform do? It will not say this, but it will say out of the two resource block, only one resource block is needed to be created. Okay, so watch this. So when I say Terraform plan, nothing to be updated. So we will edit the main.tf, and to this, I'll just add one more resource where I'm saying create this virtual environment, which is what we call it as container, and that should be available on my machine, the same machine. Okay, and the name of this. Okay. So this is my desired state. So what is my desired state? I need to download an image, and from that, I'm going to create a container. And for this, now if you do a Terraform validate, everything is fine. So let's go ahead and do a plan. And now what is Terraform doing? So you can see Terraform is clearly telling us right now there is only one resource to be created. And what is that? The Docker container, my container. So this is the resource. Okay. And corresponding to it, what are the properties that it is going to track? Unlike an image, for a container, there are a lot of properties which will be added after container creation, because right now it doesn't know anything. The only thing it knows for this is what image to take, okay, and what is the name of it. And you can see the image ID is the CentOS latest image ID, the same thing which we were tracking. And accordingly, you can see it is going to say one resource, okay. And to cross check whether something is running, you can say docker ps. So there is nothing running. So if you say Terraform apply, and now what will it do? Already image is available. So it is not doing anything. The only thing it is trying to do is add a new resource to your infra. So that way, now if you do a plan, both of them are there. Okay. What happened? Container is not created. Looks like it's taking time. So yeah, once it's properly created. Okay. So now if you go ahead and do a Docker PS, you should see, okay, it's actually getting stopped because there's nothing available. Okay. So this is the reason. So what we will do for this is I need to change this example. So now I'll do one thing. Let's Terraform destroy. Okay. So we'll take a new image completely. So what I'll do, we'll take a second example. Okay, so in this example, what I'm going to do, instead of the CentOS, I'm going to take the Nginx as the image name. Okay, so we'll do this one by one first. So I'll take the same example. I'll edit main.tf. Now I don't need these two, right? So I'll just delete it. So first I'll say Nginx. Now Terraform validate. Everything is fine. So Terraform plan. So it says it's going to create one image, fine. So we'll say Terraform apply. So you should have that image downloaded. Okay, and Docker images, you should see that Nginx image is available. Now if I do Terraform plan again, it should not say anything. Okay, now in this case we will add a new block for container creation. So what I'll do, I'll add this. So here I'm trying to tell the name of the containers to be test-ng, and it is going to take this image from the previous one, and I'm just trying to tell in the container to map port 80 so that you should be able to access. So don't worry about these options much. Even if it is not there, that should be good for us. Okay, now just to show you that we want a new resource to be added, and here if I add this, and if you do Terraform validate, Terraform plan, and you can see it says one resource needs to be created, and that is only container. Okay, and if you go ahead and say apply, and only this will be getting created, and when you do a Docker PS, you should see that there is a container created, and inside it you have Nginx running. Okay, and if I go ahead and say plan again, it will say both the resources are up and running fine, or in other way, your desired state was download an image and ensure there is a container or a small process running, and both of them are already running. So now in this machine, I have ensured that Nginx is running inside this container. So if I want to access, I can simply say localhost 80 within this machine, or in AWS, what I can do is simply come back here. So this is the machine. I can just take this machine's public DNS, and if I say 80, Nginx should be accessible. Okay, so this is where you can have more than one resources, but it depends on at what time you have applied. In the very beginning, if you have applied, then it will create both. But what we did, you first create this, and later in your configuration, you just add this block. So what will Terraform do? Accordingly, it knows which resource has to be created or modified. So that is where it always reads your current state, which is that what you have defined in your configuration file, and it compares it with the existing state. And then it knows what has to be created or destroyed, which is what the plan will be. Okay. And here, if I just say Terraform destroy, then it will destroy both the resources. You can see two resources. What is that? Image and the container, both the resources. Okay, so if I just say S here, it will destroy both. So you will neither have the images nor you will have the container. At this place, if I say plan, then it will tell two resources to be created. Okay, so that is how it will always check with your desired state, and then it manages. Okay, now if I say Terraform apply, and you should see both the resources created. Okay, and then now if I say Terraform show, then it will be giving me the details of both the resources, because it's not just managing the image, but it is also having the container details also. That is where it is trying to say it's maintained. See, this is the container, sorry, image properties, and this is the containers property. Okay, and that is the reason when you say Terraform plan, once again, it says, hey, I know you wanted these two resources and these are available. Okay, so quickly try this. I'll just paste the example. So remember, depending on what is your current state that you have given in the configuration file, Terraform will read everything. So you can add any number of resources anytime or modify the existing. when you run the Terraform plan, at that time, what is the desired state through your configuration? It will read and it will check your current state, and based on that, it will tell. Getting it? But it's the same workflow what you go through. Okay, in
Sir,
case
if,
if you guys, yeah.
if I'm having Nginx running and then I want to go back to CentOS, can I go directly or will I have to change the file again?
Yeah, so you have to tell the state. So once again, you have to go back and change the state and then rerun it. Okay, because right now, the same thing what you said, if I just change this Nginx, okay, so let's assume instead of Nginx, I'll say Apache. Okay, so if I run a plan, so it will say that there is one resource where you had Nginx first. Now, instead of that, you are saying Apache. So that's where it will try to take that. Got it?
Okay, yeah.
So it's always what you define here matters. So this has your current state, and that is also the same in desired state. So both of them are matching. So it says nothing to update. Yeah, so to try running this and see. So what I was saying is, I'm not going too deep into Docker, but just try to understand, because this will be easy for you to know the workflow. I'll share a complete tutorials if you guys are still interested to learn Docker, right? So I can give you, so you can just go through probably in your spare time, or post the training, you just try to go through that. Can you try running this? Okay, I tried.
Yes, it's done. It's working. Welcome
Yes,
to
sir.
engine. Next page is coming up.
Okay, cool. So familiar with these commands now, right? Terraform, init, validate, plan, apply, show, destroy. It's all about going forward. You know what to run. But the only thing is, let's start learning more into what is this resources, how does it work, or what are the different resources and what different functionalities we have in Terraform. Okay. Now, what time do you guys want to have your lunch break? Okay, so
1:30 is
probably.
fine.
Okay, so when did you had your lunch break for the previous sessions and how long?
It used to vary. Sometimes we used to get it at 1, sometimes we used to get it at 1:30. It used to be a 45 minutes break.
Okay, no problem. Yeah, so for those who have completed this, take a break. So we'll meet at probably 2 or yeah, pretty much 2 to 10 we will meet. But if there's any questions, I'll just be here for a few more minutes. Yeah, those who have done, take a break. Anyone else who's still trying? Any questions?
Why did we make use of Docker and not connected Terraform directly to AWS?
Yeah, we'll go into it. It's just an example that I'm trying to tell you. Okay, so this is mainly for you to understand what is the Terraform workflow, which is very easy if you go through. Next, when I tell a resource, then you should be just directly start considering like, yeah, so I know what is the resource, how does it manage? Okay, so this is where just one example.
So we made use of Docker just to give a gist of what Terraform is.
Yeah, to understand the workflow, and then we will go into those. Okay, so if there's no question, then I'll break for lunch now. Okay, but anyway, I'll be there. Just ping in chat. I'll be on mute in case if you need any doubts to be clarified. Okay, probably it's already 1:30. Yeah, let's meet by 2:15.
Okay.